Good morning, everyone. Happy Saturday. What a good Saturday it is. Here in Baltimore, even though I am wearing a sweatshirt, that's because the air is on in the house, which is super nice because I think we finally broken into spring. If not summer, it was like mid 80s yesterday, which is super nice. I think it's gonna be pretty nice today. Actually, let's see what it's gonna be today so I can get ready to know what I'm gonna wear. 71 degrees right now, high at 79, so it's kind of nice here. You know, it's making me feel very springtimey, summertimey. It's been super weird for the past few weeks. Yeah, video title should say part 2 of, oh, is it not? It says 2 of 8. It's probably cut off on your screen. It does say that in here. Yes, it should say part 2 of 8. 8-week boot camp, 1 day a week. We are on week number 2. But yes, it is beautiful here in Baltimore. Today's gonna be interesting. So I told you guys I was gonna get you guys some stuff. I consistently do this, but I underestimated how many things I was gonna have to do this week. But I still have a lot. We still have a lot. We have a lot of stuff ready, but I don't have that. I didn't yet finish the Packer image for you all to follow along via VirtualBox, but that's okay. I also, because of some things I learned this week with the other boot camps, I actually removed a ton from what we're going to do today. Well, I broke it up in a lot different way because I actually packed too much in the past 2 streams. It was a lot more information for kind of the beginner boot camps, and I realized that today was going to be, I put enough stuff in here to take us like 5 or 6 hours. So I cut out some stuff that we are going to actually include over the bootcamp. We're going to add to it over the bootcamp. So instead of having everything up front, today we're going to be presented with we're going to be presented with a number of services that our startup is going to be using to run itself. We're going to be working with those to kind of learn the topics that we're going to be covering over the next few weeks, while adding additional services and interacting with them in different ways. So should be fun. There are slides tonight. Those are not the slides 88 Opus. And actually, I don't even think, whoa, the dog's making noise. That scared me. Let me make sure. Let's go to Academy View. Make sure you get all the stuff that you need today. Let's make sure everything's in the classroom, because I don't know if it is. Let's see here. We should do slides first, because there are slides. They're very short today, but today we're talking about distributed systems, a very important concept. 1, to the cloud, and 2 to we're talking about DevOps and site reliability engineering. So not only we're talking about the setting up the pipelines and the tools and automation needed to deliver software, we're also woo, wrong pipe. We're also talking about the things that are necessary to ensure that software is, those applications are up and running, that people can access them, that they can be fault tolerant, that they can handle, failures and things like that. So this is a very important concept to mitigate a lot of the issues, or to support a lot of the concepts that we're going to be working on later. We also have a Google Classroom. Let's get it in there really quick. I have a bunch of resources for today. I think this is the only class I did not automate. All the rest of the ones are automated and get stuck into Google Classroom. This one I have not taken the time to do yet, but I have all the content for it. Let me get that stuff in there for you right now. Let's see. This is the wrong one. Let me at least get the slides in there. Oops, share. Get your link, get it in the Google Classroom. Save. All right, here we go. What's up, everyone? First off, what's up, Blue Garfield? What's up, IJ? Be that boy. What's up? Who else is on? I'm sorry if I skip your name. I skipped the people's names who are in blue or black on my screen because I cannot read them. I need to pull up a different view so that I can read what your name is. What's up, Eliolias? Yeah, morning. What's up, 88 Opus? Always good to have you. Thanks for joining us on a Saturday. What's up, Marcella? The Devo 8, good to see you. Good morning. You're a dedicated individual. YGBSM, welcome to the channel. Good to see you, Adam. Thank you so much for the sub. Really do. Lewis, what's up? How you doing? Aditya Jawkar. I did my best. What's up, Bird? What's up, Frequency Hop? Pia Murphy, how you doing? What's up, Mufasa Jones? Angry Mohawk, good to see you. Good to see you. Okay. The link is, I just shared the link. Let me get in the Google Classroom for you. And I'll add in all the resources before the class is over today. Let's see. What is it? We're on pipelines. And let's do a whole topic first. Go to diving into distributed systems and material slides. Add. Okay, they're there now. So I spelled slides wrong, but it'll be all right. We'll fix that later. So what we can do first is let's pull up the slides, and let's also head over to the GitHub for this. And I will share the GitHub if you guys don't have it, but it is in my GitHub. I'll share the link really quick. Remember how we last time we talked about how we are going to be doing a lot of stuff through GitHub projects, which I think is going to be fun, especially because I've been meaning to use GitHub projects. I've never gotten a chance to actually spend any time getting up to speed with it, but we'll use it to kind of track our progress and to start tasking out things that we need. So I'll share this if anyone needs it. And the last thing we'll pull up the roadmap.sh, because as we're going through this, if there's anyone who has not gone through or is currently going through the DevOps 12-week the 12-week course, the Intro to DevOps course on YouTube, like going back over that, or went through it already, I'm going to be trying to contextualize what the things that we're working on and what pieces of the roadmap they touch, so that you can kind of either go back, like I think a lot of it's going to be confusing to a lot of people, but if you can go back and learn and focus on the different pieces to kind of pick up what we're doing today, that may help. And so today we're going to be covering some OS concept stuff. So we're going to be doing some stuff in Linux. We're going to be, installing applications. We're going to be, we're going to be doing a lot with Linux today, and operating systems management, as well as servers. We're going to be messing with some servers today. We're going to be hands-on doing things with server. We're going to be living in that terminal over here. So that'll be good. So we'll probably be doing that with a lot of the stuff, not all of it, but in the beginning we'll be doing a lot with that. All the text manipulation, maybe not. I'm not sure we're gonna do any bash scripting today. We'll be doing a little bit with networking today as well, and maybe some CI stuff. We'll see how far we get. Cloud provider stuff, we're gonna be doing everything in AWS just for today. But yes, it's going to touch those things today. So let's talk about that. Yes, you should get clone that. Well, you can get. You can feel free to get clone that URL. It's not going to. Yes, go ahead and get clone that URL for sure. Definitely get clone that URL. You can call me IK. Drop the numbers. Cool. Where's the LK? I never know. Capitalize it for me so I know, unless that is capitalized. The K is not, so I'm assuming it's lowercase. LK, cool. All right, okay, got it. I will remember that. Appreciate it. All right, so tonight, real quick, let's just run through distributed systems super quick. There's only 5 slides on it. The concept is bigger than that. There's a lot of caveats in there. There's a lot of gotchas, but all we want to do in the beginning is we want to understand what the concept is that we're trying to do, and let's get hands-on and let's play. Let's get some things right, let's get some things wrong, and kind of see how these things fit together. We'll go over what the system is now. We'll log in and take a look at those things and get going. So distributed systems, divide and conquer. This is how you achieve things in this is how you achieve cool stuff in DevOps and the SRE world. Now, what is a distributed system? You've probably heard of this before. Like you probably heard the term distributed system, but had no context behind what it means. But a distributed system, in its most simplest definition, is a group of computers working together as to appear as a single computer to the end user. So you are the end user, I'm the end user, the people are the end users. You may have heard this before in the intro class when we were talking about the cloud. The cloud is, a distributed networked computers. So the cloud allows for the easy creation of distributed systems, but distributed systems is simply different computers network together, working together to appear as if they are a single computer, single application to the people using that system. These machines have a shared state, operate concurrently, and can fail independently without affecting the whole system's uptime. So that second line is the most important piece here. That is the reason why. The top is the what, but the bottom is the why. Why do we want to do this? It's so that it can fail independently without affecting the whole system's uptime. And we're gonna learn about some other whys, but that is the main underlying reason. That's the reliability here. That is the, that's the reliability here. And that's the biggest, I think, payoff of why you would want to distribute the system. So why are distributed systems? So if you are a fan of Guardians of the Galaxy or anything in the Marvel universe, you'll understand this. Why is Gamora throwback? But because they're fault tolerant. So we talked about in the last slide, we discussed a little bit how a piece of the system can go down and not affect and possibly not affect the entire system's uptime. So they if there are errors, distributed systems are much more they're much more durable in those cases. They're capable of withstanding failures in the pipeline. They're scalable, so that means that they can respond quickly to the demand that is being requested to them. So if a bunch of people are requesting an application, it allows distributing the system into smaller pieces, allows you to scale up or scale out a lot more easily to be able to serve that demand. And then performance. So if you have everything together, all running together using a computer's resources, that can be pretty taxing on a computer. Separating that out into individual pieces that have a slimmer pillar of focus allows for increased performance, allows things to operate much faster. What's up, Felipe Crespo? What's up, Julius Juno, Tech Daniel TV? Welcome to the channel. Happy Saturday. Thanks for spending your beautiful Saturday morning with me. What's up, Level 12 Human? Good to have you. Welcome to the channel. Whose birthday is it? To your son, Robert Shade. Is it your son's birthday? Happy birthday to whoever's birthday it is. It's my son's birthday. Oh yeah, that's what's up. Happy birthday, Robert. I want to. So on March 21st, you all spent my birthday with me here on Twitch, which was exciting for me. I'm glad that hopefully we can extend to you a happy birthday, Robert. It's a nice day. Hopefully it's a nice day where you are. Shade, I don't think you're that far from me, so hopefully it's a beautiful day. Enjoy it, especially during this wild time where you can't get out to be with everybody. I definitely hope you enjoy it. Okay, so we talked about why a distributed system is great. Sure, simple. You want to make sure it can stay up. It can withstand failures a little bit better. It can scale up to be able to serve higher demand, and it can perform much faster because it's broken down into smaller pieces, and the different pieces have a singular focus. But they can also be difficult. Just because something improves a certain aspect, which is again that reliability, that accessibility, it doesn't mean it doesn't come without its cons. It doesn't mean it doesn't come without its difficulties. And this is going to be the most important thing you're going to have to do in your technical career is this is what you get paid to solve problems, which those problems and those solutions, decisions that you make are simply a list of trade-offs. There is 90% of the time, there's no right or wrong answer. There is the best answer given the information that you have, and after looking through those trade-offs, after analyzing those trade-offs, choosing the best one that makes sense for you at the time. And that can change. At the time, a decision's great and things may change, and maybe 3 months down the line, that was a bad decision because things changed, but you can only make a decision based on what you knew now. But one of the things is these pieces are distributed and connected via network. And so network failure is a big problem and can be a big problem for your distributed system. It is another point of failure. You are adding in points of failure here, and network failure is a big one. The next one is latency. If things are not co-located in the same server or in the same place, they're not, centralized to the same place. Latency is the time it takes for the transmission of data between two of those endpoints. So from one of your systems to another system, that time it takes for the information to go across and to travel back is latency. And latency can be a huge problem in distributed systems. If you want it to feel like one cohesive system, that is something you're going to have to keep an eye on. That's something you're going to have to make sure you've worked out. And that goes along with networking. Observability, because you've broken this up into a bunch of pieces, it can be difficult to understand what's going on in each piece and how they correlate to the other pieces. And that's very important. So we talked about observability in the intro course. And like I said, we'll get there. That's a whole section on the DevOps roadmap is observability, monitoring and logging, and observability. They put it as just monitoring, but it falls underneath the observability flag. Super duper important, but it makes it difficult to be able to make those decisions based on the information you have coming in when each of the parts is separate. You've got to put in some things to make sure you understand what's happening and what different metrics mean as a whole. And then management and overhead. I want to mod someone. Look, read the chat. Oh, all right, Empathy TV, welcome, I guess. All right, cool. That should be gone now, I guess. I'll mod. We'll get a mod in a second. In a second. We're already almost done with the slides. We'll mod up, and then we'll just keep moving. So yes, management overhead. When you have a lot of pieces of something, it can be very difficult to manage. Different pieces that move differently, understanding what they're doing, understanding how to change them, how to update them, understanding how they connect to other things can be pretty difficult. So these are probably the 4 biggest difficulties. There are many others, but there are also many other smaller benefits, but I really want you to focus on the main benefits and the main difficulties. And you can see there are in here, there are more. I purposefully listed one additional difficulty as opposed to benefits. One, to again highlight the fact that some of the things that are done in DevOps, a lot of things that are done in DevOps and site reliability engineering may be mentally counterintuitive to a number of things, but it all depends on what your goal is. If your goal is consistency and reliability, which it is for most companies now, and it's the reason they're hiring for DevOps and SRE, some of the stuff that you're going to be doing is going to be difficult. It's going to be hard. It doesn't mean it's right or wrong. And it also doesn't mean that distributed systems are necessarily the correct answer in every situation. But it's a concept that we need to know. It's a concept that's important. It's a concept that's commonly practiced, again, for that reliability, for also for possibly speed of management, speed of deployments, things like that. But we want to learn how to do that thing so we can, be able to make that decision on whether or not this is right for us. And then the last slide here is the different types of distributed systems. Distributed systems generally fall into 1 or 4 different basic architecture models. This isn't necessarily super important for you to memorize, but be familiar with. There's a couple different types. So client server. Client is going to be the computer that is requesting the data. So my computer, your computer, that's going to be the client. And the server is going to be the thing it's requesting from. So clients reach out to the server for data, then format it and display it to the end user. So the server formats it and displays it for the end user and gives it back. The end user can also make change from the client side and commit it back to the server to make it permanent. So this is just directly back and forth between the computer, my computer, and the server the information is being served from. This is probably the paradigm and what you're usually thinking about on the internet. It's normally not the case, but this is the paradigm of direct from your client, from your computer, your console, over into the server. A 3-tier is the most common for web applications, but this is where there's a middle storage area. So there's a client which reaches out to some middle tier, some middle application, which then communicates with some backend server. So it's putting a middleman right in the middle to kind of handle that transmission and handle the kind of management of that data. And then there's in tier. That's if there's more of those pieces that run through, in being any number of items that allow you to move that data back and forth. And then peer-to-peer is no additional machines are used to provide services or manage resources. Responsibilities are uniformly distributed among machines in the system, known as peers, which can serve as either client or server. So instead of having a very specific client and server relationship, things can be both for one, and they can be distributed evenly amongst them. Again, just concepts I wanted to drop in front of you. I would, if you're trying to really understand different type of architectures, I would at least write this down as something to look into. There are a few more distributed systems, actually, distributed system types. These are the 4 that are commonly talked about when you go look this up, but you might find a few variations in the thing that you find. So that's all the slides. That's all the slides right there. We're done with the slides. So ask any questions you want to ask. I'm about to go through real quick and catch up on the chat. Yeah, I'm gonna catch up on the chat, but ask any questions you might have. Could a 3-tier or n-tier could be, that's a question up. So how would distributed systems and multiple web servers with a load balancer, or is that a distributed system? Yeah, yes. So there's also another concept here that maybe I should put a slide in here for. There's distributed systems and there's decentralized systems. So decentralized systems are a form of distributed systems, but they're not distributed systems in the terms of what the original definition was meant for. Decentralized systems are more of what you're talking about there, those load balancers. We will actually get into that. We are going to be decentralizing pieces. We're going to be decentralizing pieces of our distributed system. So we'll highlight that as we kind of get in there. Yes, the internet is if you're going to focus on the internet itself, yes, the internet is a distributed system. When you hit your browser, to you, all of it looks the same. Like, it looks like this is one thing for me. This is one tool for me to use, which is the internet. And I can go to different sites. It is I guess it's a high level, maybe the most pure of distributed systems. Are we going to implement things as distributed systems? Yes, we are. Yes, we're going to do that right now. Actually, we're going to take I don't even want to call it a monolith, because the repo it's not a mono repo, but I guess it's a monolith. We're going to take that today, and we are going to do our best to, however far we can get in the time, and distribute those things. Jasterix, I feel you on. I just got my coffee before this. It's already gone. I usually brew my own, but this morning I was running late, and I was like, I have a Dunkin' right down the street, and I was like, you know what, I'm gonna just go grab an iced coffee. It's a beautiful day, it's iced coffee season, I guess. So I want to try that out. Opposite of a distributed system is, in fact, a monolith. A monolith is a monolith, which could be an answer. A lot of people nowadays, monoliths have gotten a bad reputation, a bad name, but it's funny. Everything goes in cycles. Everyone who's worked with these distributed systems, there's been a rush recently to distribute. But again, people never took into account the complications these things may cause. You may not have the underlying infrastructure personnel to deal with those things, and people have been shifting. There's actually been a shift back to the monorepo, back to the monolith, having everything in one place. There are benefits there, but there again, this like the inverse benefits and cons occur. Like you flip these on their head, just flip it around. The good things that are good here are bad there, and the bad things that are bad here are good there. So it's been pretty interesting. And I want you to know that, like, I really want to go into this because everyone always told me, yeah, distributed systems is the way to go, and you know, all this stuff. It's like, again, depending upon your use case. I want you to know that all these things that people are saying are just options. They're options that solve problems. So understand what problems those solve, but also understand what issues those things create. Sean from LA, just I know the Saturday one was tough for me to pick a time. I had to do 10 for a number of reasons, but I knew it was early, especially for the people on the West Coast. My bad. I'm sorry. We'll figure it out. Doing Linux stuff. Yes, we are going to be about to do some stuff right now. Awesome user, Twitch user. Everyone's one day we need to make a list of names. Like, everyone has such cool names. Which distributed system we'll be working with? We're gonna be working with we're gonna be distributing a system that is not currently distributed. We're gonna be distributing it. We're gonna be decentralizing it and distributing it, but sure. Okay. What is better? Again, distributed system for centralized. It all depends on your use case. It depends on I would say for reliability's sake, and for reliability's sake, distributed systems are they're better. Distributed systems are better for reliability's sake, and to ensure that, you know, your services are always accessible. But I think centralized services, centralized systems are better for management and overhead. So if cost is a thing to you, you may want to factor that in. You may, yes, a centralized system may be harder to keep reliable. It may be less fault tolerant, but the amount of people you have working on the project, the amount of overhead that goes into fixing issues when they happen, because it's simpler, you may want to say, hey, I can accept a little risk here. I can accept a little downtime because it's actually cost me less money than paying for the management of a distributed system. It gets pretty complicated, but there's no right or wrong answer there. Let's see. Yes, you can use monorepo. Monorepo does not equal a monolith. I dislike monorepos, to be 100% honest with you, but that's just, it's personal preference. There again, trade-offs. I also have the way my brain works, it's fine for me to mentally jump through a bunch of disparate systems, but I know a lot of people have immense trouble with it, and I completely understand, but I think that just has to go into my systems background. It kind of helps. I don't really mind it, but yeah. Is it better to save PDF files of 1 megabytes into a DB or file system? That's a great question. That is a really good question, Tram Stars. And these are the types of questions I'm glad we're getting on a Saturday. I'm glad, these feel like the intermediate DevOps systems questions. Again, that's also an interesting thing. I'd actually say a lot of people do them in both ways. They'll save locations of PDFs in the database and serve them directly from the file system. Again, a lot of that depends on your system and your machine latency and speed, and the way that you're transmitting that data, whether or not people are grabbing them immediately, whether your system's grabbing them to do some processing, all makes a difference. But it's a great question. And we're going to be doing some database stuff, and maybe we can do a little bit of profiling to kind of see some speeds. See some speeds. You uploaded Fulcrum cache folder. Oh yeah, Oh, that's fine. Completely fine. This is for us. Yeah, I'll probably delete it just so it's smaller. And I did not make a git ignore. But that critically git ignore won't really matter quite as much, because well, it'll matter more once we get to the section where we're going to be actually setting up some pipelines for this stuff. Fulcrum is just going to be one of the applications that we're using. That's a good look. I'm glad people are looking at things like that. These things are very important. I want everyone to start calling out those things as well. Things in the system that that can be approved, things in the system that we're not doing right, that we've missed. Call those things out. This is going to be, like I said, this is an exploratory. The things that we're going to be doing are more exploratory. So like, I've actually never used Fulcrum. I grabbed a couple, I looked up some open source applications that people might use to run their business, and kind of got those things up and running. But yeah, let's actually take a look at that, like actually what we're going to be using and what we're going to be getting into. So I'm going to log into console.abws.com. So I'm already logged in here. All right, so in the repo, you will see I added some services. We are a startup. This is the pipeline startup company. We should think of a name. Maybe we'll start a poll today to figure out a name. But that was a part of the introduction, that we are hired with a new company, a new startup that's doing pretty well. You know, their product is selling. Their products are selling. They're making good money. They're really growing. They're really poised to blow up. But all of the infrastructure, all of the architecture of the site was kind of just done by the founder, and kind of just, you know, hand-fisted onto a server, and everything's just kind of there. There's a couple things that run the company. All of the company services exist in this one server. There's actually, I only put these things in the repository because I wanted you to be able to more easily see the pieces that we're using in case you want to install some of these things. I was just gonna make a list with links to them, but this repo is not actually being used at this company yet. Fulcrum, which is a product management tool, open source project management tool, that is something that's running on the system. So I'll click on it really quick. This is something that the startup uses to manage their workflow, to manage their projects and products in the background. So this is a company, an internal company tool that is running on the server. It's essential to the business functioning, and it is something that is installed on the servers. Again, it was installed manually on a server. I forgot what pieces this has in it. It's a Ruby. This is a Ruby on Rails service. So that's one thing that's good to know. And I think it's using its own development database. So it's using a development database. That should already be telling you that we'll probably need to move this. Probably need to give this a real database at some point, and no longer use the development database. But we're going to see it in action in a second. So yes, it's the project management tool that our company is using. Then we have Rocket Chat. Rocket Chat is there needs to be a README in here, but Rocket Chat, I spelled that wrong. Rocket Chat is it's a open source Slack alternative. It's pretty cool. Rocket Chat's pretty heavily used, but you can self-host this. You can self-host Rocket Chat if you want. And so we have a self-hosted Rocket Chat. This is how the company speaks to each other internally. This is how we'll speak to the other people in our company. This is how they'll, speak to us as well. This is how we'll collaborate with the members of the organization. So there is a Rocket Chat installation on the server. And then there is actually the last tool. So we're only introducing 3. We will be touching 8. There will be 8 tools. There are actually 8 tools that are underlying, that are running the company, that are there. The problem was, learning from this week, we were never going to get through today if I didn't pull some of those out. And so I found some strategic places to implement those during the process, and kind of learn how to implement new tools into the processes and pipelines at different points in the pipeline. Because over this time, we're going to be creating a whole, an entire pipeline to be able to serve these things, to be able to, push new code, to be able to ensure things are reliable. We'll do some load testing and see some cool stuff, and how things respond. But the last thing is our blog. So the company does have a they sell products and services. It's a startup. They have a product. They're a product company. And so there's an e-commerce site right now. It is not something that's hosted here. This is something that the founder did in fact pay someone else to do and manage. So we're not worried about that right now, but the goal is to eventually bring that that e-commerce section into the fold here. That will be part of what our job is. But right now, we are not managing the e-commerce section of this, but we are managing the blog, which drives tons of traffic to the e-commerce. You know, as startups go, we're big on social, and we've gotten the things that we put out are kind of big in the community. We're starting to become a kind of thought leader in the space, in this product space, and so there's a pretty important blog site that we have that gets, like I said, is super popular. It is a Gatsby site. And so it's JavaScript, Node.js, React, and it's here. I just grabbed a starter theme. We'll modify it. Not important that, you know, it's an actual blog, but it is a blog site. It will work, and we'll be using this as our as the thing that's going to represent this site. So 3 different services. Again, we have we have 2 internal services. So one of the internal services is our chat, our collaboration tool, our Slack alternative, which is Rocket Chat, pretty dope product. The second is our project management tool, which is called Fulcrum. And then the third is our external blog site, which pushes, you know, our informational site, which pushes traffic to our e-commerce site, which we don't yet host, but we will be thinking about that in the future, thinking about how to incorporate that in the future. So these things are currently installed by hand, as they would be by, you know, the founder of a company who's a software dev, you know, no shot at software devs, but who's kind of learning the infrastructure pieces on the fly and is sitting on an EC2 instance out here, running instances, sitting on this. We're gonna have to. I might start moving some of this stuff to a different region, because we're doing a whole cloud course, and I kind of don't want those things to get mixed up to confuse people when we get in here. But for now, we have this. So we have a server here. We have a T2 medium. We have a decent size server here. And we're gonna get logged into it, and we're gonna see. I'll share this out. Great question. What is EC2? EC2 stands for Elastic Compute Cloud. I highly recommend you take a look at some of the, actually we went over EC2 this week. And Horizons, the Horizons videos, so all videos from this week will be up today. The only reason they're not up, I should have sent out a message. They're not up because I was in the middle of the application for, we finally hit the stats for YouTube monetization, and you don't get paid retroactively for views. So I was like, I'll hold off until they accept it. I didn't know how long it was going to take them to accept or deny it. They did accept it yesterday, so those videos will go up today. Not that the goal there is to make money, but if I can make money, like if people are going to watch it anyway, I figure have it be monetized first. So all videos from this week will go up today. I think Mondays is up, but the rest of the week will be going up today along with this one. So that works. So yes, the link does not work. The link should not work. Sorry about that. Should have told you the link should not work. We're going to show you that in a second. But yeah, EC2 is just a server. It's a virtualized server in the cloud. So it's a computer. It's just a remote computer. It's a remote server that you can access, that you can install things on. So it's a Linux system. It is an Ubuntu system, and we're about to log into it right now. But yeah, I appreciate it. It's funny because I don't make, like, I plan on making YouTube videos, but I haven't been doing that because I've been focused on the streams. So it's interesting to see that I had enough like view time. I didn't realize like 4,000 watch hours is a lot. So thank you all, to be honest. We also applied for Twitch. We hit the numbers for Twitch sponsor partnership. Applied for it. Everyone tells me you won't get it on the first go, but whatever. Just super excited to kind of hit that milestone. So I appreciate all the support, all the love. Like, honestly, we did this together. So thank you for that. Thank you for that. Do you have the AMI? I'll generate an AMI. I don't have the AMI only because I pulled a bunch of stuff out of it. And I just didn't, like I said, this week I got caught up and I did not get to do all that I wanted to do. I'm also gonna, not only are we gonna create an AMI, but we're also going to create a we're gonna create a Packer job that builds a Vagrant image for this as well, so that people can do it locally, because it's kind of annoying. But we can, AMI creation, for people who don't know, it's an Amazon machine image. I can basically give you an ID. I can basically take a snapshot basically of the server as is, with the things installed on it already. You can take that ID and you can spin up your own server in Amazon and have the same exact stuff. And actually, let's see. I think I have to. We'll do this closer to the end. I'll take a snapshot of it, and then using that snapshot. I don't think I have any snapshots of it right now. Using that snapshot, I will go ahead and create an AMI for you. Is it similar to DigitalOcean Droplet? Absolutely. Yes, it is. It's very similar. For all intents and purposes, think about it like a DigitalOcean Droplet. DigitalOcean Droplet is actually something called a VPS, which is a virtual private server. This is similar, very similar, but Amazon does have its own. A lot of people don't know this. Amazon has its own thing called Lightsail, which is the true equivalent to a droplet. And Lightsail is very similar to EC2. I actually would we probably should have used Lightsail for this, to be no, we shouldn't. Well, for this initial run, we should have done that. It's cheaper. You don't have as many options. It's not as flexible. EC2 operates the same way, it looks the same, but underneath it's split up in a way that allows you a little more flexibilities. But yes, very that's a good connection there. Credit card is necessary for AWS. Yeah, it is. But there are free tiers of things. While I guarantee, the reason why I said I'm going to make a Packer image to create a Vagrant image for you all is because for the Horizons course, I can guarantee that we're going to use free stuff. That's not the case here. We won't. You can use free tier stuff, but I can't guarantee it's not going to cost you any money, because we'll be doing some stuff with RDS. We will be doing things that will cost you money if you do it all inside of AWS. Just as a caveat, we'll try to spin some stuff down. It'll get easier when we get the automation in, but I can't guarantee that here. All right, so let's get logged in really quick. And I'll try to talk through, so we're not going to spend as much time as we do in the apprentice level courses, like stopping to go through things, but I am going to do my best to say everything that I'm doing. Like, even when I'm just logging into an instance, I'm gonna do my best to say it so that you can have something to write down to go look up if you're completely confused about what I'm doing. So what I'm doing is I'm grabbing the DNS address. I need to log into the server, and the server has a web address that I need, that my computer needs to know so they can get to it. So I'm grabbing that web address so that I can log into the server right now. So I'm going to go into my terminal now. So we're gonna be doing a lot from the terminal now. So I have all my keys in a directory right here. So I do have a key here. You cannot log into AWS servers, so like DigitalOcean droplets. You can log in with a username and password. At least last time I used a DigitalOcean droplet, that is not the case with EC2 instances. You cannot log in via username and password. You must authenticate via SSH key pairs. It's SSH key based authentication. So there's basically a lock file and a key file, and the server has one and your computer has the other. And when you try to connect, they talk to each other and they say, hey, do you have the thing that's going to open this lock? And yes, you do. I will allow you to get in. So we're gonna go ahead and log in using SSH. SSH stands for Secure Shell. This is how you connect to remote to Linux computers. So over a network, this is how you connect to other Linux computers. SSH-I. The -I is going to say, all right, I want to connect via SSH. SSH, usually you could do a username and password. You say, hey, I want to make a secure shell connection to remote computer number 1, and remote computer number 1 say, hey, cool, what's your username and password? And you'll type it in and you can get logged in. That does work with SSH, but that does not work again with this. So you have to say, here is the file that I'm going to use to verify my identity. And that's what this I is. And so I'm going to point to the right file that I have here. So SSH-I and the file that I'm using. And so I already set this up previously. And like I said, head over to the EC2 video that I'm going to put up today. If you need it, you can also go back to my YouTube and look at the ones from the previous DevOps course to kind of understand that a little bit. Or sign up for if you sign up for the Google Classroom for Horizons, there is a whole video series in there from YouTube on how key-based authentication works. So the user for this server is Ubuntu. Every Ubuntu server on AWS, this is the user that you have to log in with. And then I'm going to paste in that address. So I know this can be a little bit confusing, but this path gets way more comfortable as you go on and on. So it's SSH. The real, so the normal way you do something is, actually before I do that, is this is the breakdown. SSH, the username you want to log in as, the @ symbol, and then the address of the computer. So I'm just gonna put IP address. So this is the normal makeup of an SSH command. It's kind of simple at first, and so SSH, whatever your username to log in that computer is, and then the IP address to get there, or the DNS address. But because we can't use username and password, the only thing that's different about this is, so Ubuntu this would be the command here. This is my web address. This is my user. And the only difference here is I have to tell it which file to use. So -I pipelines. What? Whoa. Okay, there we go. All right, so that's going to take me and it's going to log me into my remote computer. Now it says, welcome to Ubuntu 18.04. And it gives me a message of the day. It gives me a welcome message. It tells me, a little bit of information about the computer. Lets me know if I have any security updates. Lets me know the last time I logged into. Wouldn't our IP address need to be whitelisted to access the server? Oh, great. Excellent question. What application are you using to write the code? When we start writing the code, I'll probably be writing in Vim, but you can use VS Code. Visual Studio Code is what I recommend, but we'll probably be writing in Vim. Why are we writing in Vim? Because like now, the systems that you're going to be managing probably won't, they're not going to have a graphical user interface. So while I don't necessarily think you need to use Vim, Nano is another one that you can use. So it's a lot easier to use from the command line. I do encourage you to learn how to use that. Now, we won't write everything in Vim. I do think when we get to some of the other things, just for ease of use, just for less confusion for a lot of people, we'll use Visual Studio Code, like when we're building stuff via Terraform and stuff. But again, that's more so for you than for me. I'm a Vim user, but I've had people be super confused. Like I just had someone message me to find out, like they were trying to follow a tutorial that, editing the file wasn't the concept, but they were doing exactly what I did. And we went into Vim and they couldn't see how I got out. Like they tweeted like, hey, what did you do after you typed this? And I was like, oh man, okay. That's interesting. So yeah. I would say download Visual Studio Code, but we will be using, you'll see me using Vim a lot of times, but you can use whichever text editor you like. All right, so I'm on the server right now. This server, let's see. It's got, this is a T2 medium. It's got 4 gigs of RAM on it, free-MH. Yeah, 4 gigs of RAM, and we still got a little bit of free space. So we got a lot of free space. All right. On this server is not fully set up. There's still a number of pieces that we need to set up. But on here, I have everything in var dub and var www. So for anyone who's never managed a Linux server before, or served applications off of a Linux server, again, Linux is just a bunch of files and directories. It's not all that special. Like, it's not all that confusing. It is files and folders. That is what the operating system is: files, folders, and executables. But files and folders, I want you to think about it like that. It should hopefully it'll make it a little less scary. So everything, when you need to configure something, and once I learned this, it made everything so much easier. Whenever you whenever you need to configure a Linux service or something, it's just a file. Like, you just gotta go find, you gotta look and see what the right file is, and all you're going to be doing is changing some options in the file. Like, it made everything so much simpler to me when I realized, like, oh, it's not all this fancy stuff, it's text. Like, you're literally going in and modifying text, and it made me it made it so much easier for me. So let's see. But people asked about IP. Someone asked about IP whitelisting. No, I do not need to whitelist your IP. There are security things that are in place in AWS. So the one that AWS is using out of the box is something called security groups. Security groups are a kind of a virtual firewall that sits out in front of all of your stuff. And it's service or port based. So basically, you can only access the server through ports that I say you can access it through. I've already opened up the necessary ports here. The necessary ports that we're going to be working with today are 80, 3000, and 8000, I believe. If not, we can open up some more ports. But you can access it. You will not be able to log in to my server. You don't have this key. Yes, you all won't be able to log into this server. So I hope I didn't confuse anyone. Hope I didn't confuse anyone. All right. Let's see. How do I start? What do you mean, how do you start? If you're trying to follow along, if you're trying to follow along, you won't, you're not really going to be able to, because these, again, we're operating from the paradigm that some dude, the guy who started this company, installed all this crap on the server beforehand. And we're going in as the new infrastructure SRE DevOps person that's been brought on to kind of figure out what the heck's going on here and make some stuff work. So these three applications are here. We'll go into this Fulcrum directory and see them all in action. This is a Ruby on Rails service. I'm not crazy familiar with Ruby on Rails, but I think I just type in Rails and S and it'll serve. That may be right. I think it's in the README. Okay. All right. So it's running on port 3000. So let's see if we can find it. Now, that link that I sent, you all should be able to get to this. So if you put that link in the browser and then put in a :3000, you should be able to get to a page. So this is our Fulcrum. This is our project management application. And so first off, let's talk about what it means when we typed in, the IP address :3000. And I don't think we've discussed ports at all. All you need to do right now to think about ports is they're just different. They're simply different methods of communication. They're different channels of communication. Ports have numbers. Only one thing can be running on a port at a time. Only one service can be consuming a port at a time, can be listening on a port at a time. So once something is running on port 3000, nothing else can run over port 3000. And we'll talk about, we've talked about some of the common ports, but the port that the internet runs over basically is port 80, which is for HTTP. It's hypertext transfer protocol. But most of the things you access over the internet nowadays is over port 443, which is HTTPS. When you see that little lock in the browser and thing turns green, that's over port 443. That is, the secure port. It's running over TLS. But that's what the colon allows you to pick the port. So when you just type in google.com, by default, by default, it's going to reach out over port 80. Like when you don't put anything after it. Some things happen in the background, which pushes it over to 443 for you automatically. But to tell it to go to any port besides 80 or 443, you need to put that colon there and then type in some numbers, and that will tell it to go to where it needs to go. So type in the address and I'll paste it again. This is the address you're going to need. And then at the end of that, just put the colon 3000, and that will take you here. All right, so that's Fulcrum. Like I said, I actually don't know there's a test password. I haven't done anything besides the test stuff. I think in here, there's a test password. I don't care if you guys log in and break. I mean, you're probably gonna break the server because it's not that strong. We can make it bigger. Not that big of a deal. Let's go into Fulcrum. There's like a test username and password. Try not to break it. Try not to break it. Maybe I'll remove it. But if not, we can fix it. It's not that big of a deal. We're gonna be putting some automation around this anyway. What is it? Testexample.com and test pass, which obviously you would never want to put your username and password for things in your repo, but you know, there's this test project here, so you can see this. There's this application. It's open source. This is the thing that our company has been using to you know, follow its stuff, and you can move the stuff. Oh, maybe you can't. Start to done. What? I don't even know how this works. Finish, deliver, accept, done. I don't know what we're doing. All right. So yes, the username is it's in the README. What is it? I already lost it that fast. Where was I? Oh, the username is test@example.com and the password is testpass. Go for it. Try to log in. If we overload the server, that's fine. We'll fix it. But this will be a good indication to start to show you why this reliability is important. It'll also start to show you why, if you overload this one application, how it affects the other ones as well. So that's one of our applications, just so you can see what it looks like. The other one, let's see what the next one is. And I can see you guys accessing it right there. Actually, it just cut off actually, because sorry if you just got in there. I'm only running one of these at a time. So I stopped the service so that I can show you the next one. We're going to start them all up. We're going to start them all up. We're also actually going to put them behind. We're going to grab a domain today as well. So that was another thing we're going to touch, was the DNS portion of stuff. We're going to grab a domain and we're going to put some stuff behind the domain so we can access all these things at once, but after we distribute it. So what's the other one? So that's running normally. It's a Ruby on Rails service. So remember that. Start to commit these things to memory. They're all completely different. That's a Ruby on Rails service. We need to be cognizant of that. The next one is Rocket Chat. So Rocket Chat is actually a Docker, so this is running it via Docker. So it runs completely differently, and it's using this Docker Compose YAML. So you don't need to know Docker right now, but you just need to know that this is running in a completely different paradigm than the last one. The last one was Ruby on Rails, started manually. This is running via Docker, and it looks like it has a number of services in here. It's using MongoDB, Mongo Replica. It's using a bunch of stuff in here, but we don't really care about that, because to start up a Docker file, a Docker Compose file, all you got to do is Docker Compose up. So I'm gonna run Docker Compose up really quick. Couldn't connect to Docker daemon. Oh, actually, let me sudo root really quick so we don't run into this stuff. cd Rocket Chat Docker Compose. And this is a common paradigm where different services will be running in different ways. It seems like the guy who runs the company was starting to get Rocket Chat set up, and he probably went in and was like, I don't know how to do this. I don't know how to install this, but he saw, a write-up on how you could do it via Docker file, and went ahead and did that, but didn't go back and Dockerize anything else. So let's check out Rocket Chat. I don't remember what port this is running over or how to get here. So let's look at Rocket Chat really quick and see if we probably can't see it. It's probably the same thing. Is it? We'll check the Docker file real quick to see. Oh, okay, the same thing. Now this is replicating another concept. We already had something running over port 3000 before this. The Ruby on Rails service, Fulcrum, was running over port 3000. If you type in the same address on port 3000, it is now serving you a different application that can only be done because because we stopped the other one and started up this one. Okay, that's very important to know. And so if I go back, so watch this. Actually, I'm gonna stop this real quick. I'm gonna run it in the background so that it's just permanently up for a second as soon as it stops. And I'm gonna go back to Fulcrum and I'm gonna try to start it back up. And you're gonna see that it can't start up. It's gonna fail to start. This is one of the things that took me so long to understand. I couldn't understand, like I'll run into these errors all the time and I couldn't figure it out. So I'll run it in the background. So Rocket Chat is about to be up and running. So if you refresh, it's still there. Maybe not. It's refusing to connect. It's still probably still doing its stuff. Let's give it a few. All right, so look at it up top here. It says pipeline startup code. You probably can't see that. But if we let's go back to Fulcrum. And if I try to do Rails S, what did I use to start it last time? Oh, okay. This is because I'm root. That's whack. I forgot Ruby's weird. Ruby's super weird when it comes to that. Rails S. No, what did I type in? History. Oh, Rails server. Oh, okay. All right. Server. Oh, maybe it is telling me there's an error, but this looks like it's saying that Rails S is, yeah, it's giving me a usage template. Oh, I'm in Rocket Chat. Never mind. I'm in the wrong folder. All right, so look at that. That just doesn't even look good. It says error, E address in use. This is commit this to memory. Commit E address in use to memory. It says it here, address is already in use. So basically what it's trying to do is it's going to the computer and saying, hey, I have a service and I want to bind it to port 3000. I want to bind it to this listening channel so that it can serve information over this port. But again, that port is already consumed, so it cannot. And it says, whoops, well, I can't just give you another port. You said 3000. I'm going to give you 3000. I can't give you 3000. So sorry, you can't work and you are going to have to stop. So that's what happened. So again, knowing that ports, only one thing can be listening on a port at a time is important. So you say MongoDB uses port 3002. That does not matter because we are using Docker to run that. So again, we're throwing 20 different infrastructure paradigms at you immediately. So Rocket Chat is running in Docker. And Docker allows you to basically package up all the little tools, the libraries and binaries that are necessary for an application to run in this image, and then it allows you to run them in an interesting way. But yes, these things are running over port 3000, but well, Mongo doesn't. Mongo runs over port like 27 something, I think by default. Rocket Chat is running over 3000. Let's see. So actually, we're not even using ports to talk to Mongo. I think we are simply talking to Mongo directly through. Yeah, Mongo runs on like 27 something or something like that. Yeah, 27017 right here. but our Rocket Chat application is running on port 3000. We can easily change that. But I wanted to show you that point, that they both couldn't run at the same time. All right, so let's do, what are we doing next? So that's this running. You saw Rocket Chat running. And then the last one is the blog. So the blog's gonna be a little more interesting. Not interesting. The blog is using something called Gatsby. What Gatsby is, it is Node, it's Node.js, and it's React. And generally that would mean you'd have to run a Node server on your computer, but that's not the case here. Gatsby is a static site generator. It does server side rendering. So instead of the client, so instead of my computer reaching out and requesting information to the server, and the server responding with that information, and giving me information, and the client rendering out the page, what happens is you remove the processing from real time. So you instead of having that normal interaction happen, you pre-render all the pages, all the possibilities beforehand. So it's very interesting how this stuff works, but just know that it takes what would be normally a dynamic website that needs to go back and forth between servers to grab data to be able to create the thing that it's delivering to you. That no longer needs to happen, and you can generate it into a static page like a normal HTML page. So while this is a React application, it all ends up getting boiled down to HTML files in this folder. So you can actually just go straight to this site, straight to the URL that we have without anything else on it. So just click on the URL, and it will take you to this. It'll take you to Ghost, which is our blogging platform. And so this is our self-hosted blogging platform. So this is a dynamic site that has been has been rendered on the server side to be a static site. So our blog is a static site, but it actually is an application in the background. All right. So 3 tools. Again, most things you're going to work on are going to be with multiple services, multiple tools. And right now, all these things are running on the same server, all of them. So the company's growing. There are, all this may have been fine when there were 5 people on the project at the company, but now our Rocket Chat has 400 people in it, and our blogs are getting millions of views per month, and our project management tool is actually covering the scope of 400 projects right now. People are in there all day. So you can imagine that the server that we have this on, ignore that we're actually using a medium server, a T2 medium, but we've essentially, you walk in and see that this is actually being served off of an extra large server, so we're paying a lot of money per month for it. But also the server is still struggling because, again, during peak times, not only are a lot of people hitting our website, but so our server is responsible for serving up all those web requests, but we're also all inside of the chat app, and we're all sending messages to each other. Gotta send the memes, gotta send the gifs all day long, and we're sending videos, and we're talking about work, and we're also managing our projects, and that's a huge toll. If one of these things is overloaded, so if we're sending too many gifs, sending too many pictures, all that stuff, and Rocket Chat is eating up too much stuff, it will affect performance on the site. It can cause the site to go down. It can cause the whole server to go down. And we have a problem with one. Essentially, it's likely we'll have a problem with all. So that is the scenario. That's the setup. Those are the 3 tools that we have. Really, the fourth tool that we have today, and the only reason I didn't make a repo for it is because I think we're gonna have to create it now as we go through this, is Nginx. We do have a web server that's going to manipulate all of these things. We're using it as a reverse proxy, but we have Nginx as a reverse proxy that's going to be managing all these things. And we'll also show you why those ports, how we're going to handle working around those ports. So we're gonna do a lot, and we're gonna do a lot in a short amount of time. The goal today is to get at the very least, get these decentralize the entirety of the work applications, and also for the things that require databases, the things that require different pieces, is to hopefully, if we have time, separate those pieces out. So applications like Fulcrum that require a database, but also have a front end component to them, an application to them. Decentralization and distributing is actually the act of separating those things. So you might think we're just putting Ghost on a server, on its own server, and then putting Fulcrum on its own server and putting Rocket Chat on its own server. Yes, because these things are required to run the business, that is a form of decentralization, and it is a form of distribution. It really is. But usually when people are talking about distributed systems, again, remember, go back to the definition. We're talking about taking multiple pieces and making it appear, separating them and making it appear as if they're one. So we're actually going to separate the nodes of the databases. So the database server will be one place, the application server will be in another, and they'll be working in tandem to appear as one. So we'll try to do all that today. And the reason that's all we're doing today, not all we're doing, one is that's going to take some time, but what is that going to get us? You might be saying, oh, we're learning DevOps and SRE and automation. Why are we, you know, it feels like we're not doing, I don't hear any of the cool buzzwords that I want to do, like Terraform and all that stuff. That's coming. But this is generally, one, how you would learn how to do this stuff. And two, this is generally the process that an organization will go through to move from something like it is now to where we're going to take it. It's usually not just that big jump to straight to the automation. One, you wouldn't understand how the system worked, for one, and two, like, again, that's just generally not how these things work. You know, it takes, yeah, you can do it, and but a lot of times there are organizational blockers, there are systemic things that cause you to have to work in this way. So we're going to incrementally transition this system. So this is like you're going through a full digital transformation here, so starting from the bottom. So first thing we're going to do, let's get a little more comfortable with Linux. So we learned Linux in we learned a little bit of Linux in intro to DevOps. Let's start to use those tools. Let's look at these different applications that we've never seen before, and let's figure out how to install them. Like, let's figure out how to, like, actually go through and read through the documentation and read through the readmes and try to get the stuff installed. We're going to run into some problems, guaranteed, and we're going to see real time how you have to work through those things, and we're going to see real time how you have to how to read errors, how to search for things. We'll there's a lot in here. There's a whole lot in here. So for time's sake, let's get going. So we should write ourselves some tickets. Let's write some quick tickets really quick. So I do want to start using projects so that we can follow this. We have this pipelines project, and today let's do, I'm going to delete this note. I'm going to keep it simple. We're going to flesh these out better because there is I think next time, actually, we're going to talk a little bit about Kanban, a little bit about Scrum, Agile Scrum as well, so people understand kind of what this is. But we're going to create this little, this task here that's going to say, move Rocket Chat to its own server. So again, this is the in the simplest terms of distributing a system. We're going to talk about some things like this. So it's also worth noting that Rocket Chat itself requires multiple things. It needs MongoDB to run. It actually requires a MongoDB replica to run as well, plus the Rocket Chat service. It has actually already been broken down into a distributed service. So a distributed system does not, it also doesn't mean that it has to reside on different servers. I want to be clear about that. A lot of people confuse that. Generally that's the idea, but it does not mean that you have to put it on a different server. I know that can be confusing, and I've had people argue with me about this a lot. I argued with the person who originally told me that a lot, and they sent me some videos and kind of talked through it. Again, it's just a form of nomenclature, but really Rocket Chat is already kind of broken down using Docker Compose into that. It's available to be a distributed system, but it's kind of broken into the pieces that it needs to be already. But we're going to move Rocket Chat to its own server. We do want to separate out Mongo from it, but not right now. So we're going to move Rocket Chat to its own server. we're gonna move Fulcrum to its own server. We are going to move what's the last one? Rocket Chat, Fulcrum, and move Gatsby site to its own server. And you might think it's going to be a copy and paste job. It's not going to be a copy and paste job. We're also going to install, create Nginx server, Nginx proxy, to be able to access these through subdomains. And so we're gonna buy a domain and we're gonna put it behind all this stuff. So a bunch of stuff. There's a lot of stuff, and we're gonna get through it in an hour and 45 minutes, hour and 40 minutes. We're gonna do it. We're gonna do it pretty easily. Not easily, but yeah. So Rocket Chat's gonna be the easiest because it's in Docker already. We're probably gonna end up we'll take the time during this course to determine if we think it's worthy of Dockerizing the things that we already have that aren't Dockerized. We'll also take some time as we introduce new services. Like I said, there will be a number of new services. There's going to be the e-commerce platform that the company uses to sell its products. There's going to be there's actually going to be another caching service to support that as well, and a few other pieces. But we're going to determine whether or not those things should be containerized or not. And we're going to learn how to make those decisions a little bit, or at least again, there's no right or wrong answers here. There's trade-offs. Maybe it will determine for our use case that we're not going to do something manually, or that we are going to do something manually because of the amount of time that we have and the difficulty of actually automating that process. You gotta trade off money, time, amount of resources to upkeep. All those things go into it. So let's get moving. Let's get going. Is it one of the apps that we'll need server once we have it? Hold on, let me see. Let me go back through these. So everyone can actually see these tickets here inside of the GitHub repo. Just go to the top and click projects. And we'll try to flesh them out a little bit more. Okay, yes, talk about the reverse proxy. That's great. I really like reverse proxies, especially Nginx, because I think it's one of those concepts that it's like you may not understand it, but as soon as we implement it, I think it's gonna make perfect sense. I think you're like, oh my gosh, like that's great. Like that clears it all up for me. So hopefully we'll get there today. We will. And again, this is also gonna be fun because I ran into, like I said, I've never used Fulcrum. I've never used my own Rocket Chat. And actually Rocket Chat was gonna be the one that was not containerized. We were gonna containerize Rocket Chat until I realized how interesting it was gonna be to do that. And I actually could not get Rocket Chat working in a reasonable amount of time without Docker. So that's why we chose that one to go into Docker. I had another idea for Docker for what application was gonna be inside of Docker, but all good. 3 completely different types of applications. And so we're gonna get to learn a little bit about managing these things. So what we're gonna do first, let's go in and let's create 4 server instances. 4 server instances. And we're gonna do this on Ubuntu again. What's up, YG Dev? We're gonna do this here. We're gonna do Ubuntu. And I'm gonna make them smalls for now. I'm gonna make them mediums. I'm gonna go, I just gotta remember to shut them down this afternoon, or when we're done. I'm gonna make them mediums. I'm only gonna make them mediums, again, because of things you run into. When I tried to install Fulcrum, I could not get Ruby to do the things that I needed to do when it was on a small instance. So because of that, I'm gonna make I'm gonna make 3 smalls and 1 medium, just in case I forget to shut them down. I want to mitigate my the financial risk to myself. So right now we're not worried about the infrastructure. We're not worried about the security of things yet. We're basically replicating what is there, but each in its own individual silo. Why are we doing that? One, so we can practice distributing a system and kind of seeing how you can get disparate pieces, separate pieces of a system to work together and to talk to each other, and to appear as one. Also, we're doing this to set us up for being able to work through some of the future tasks here. So if you go back to the pipelines, what's this thing called? The job down here. We're getting this into a place where it's going to be very interesting to start to implement number 2, and then number 3, and especially number 4. We're setting ourselves up to, we can see the roadmap. The job has the roadmap right here. And so we're setting ourselves up so that we can start to separate out these pieces. It's going to make it easier for us to implement some type of development strategy against all of these things, because we've separated them out and we can focus on one thing at a time. And so like next week, that's what we'll be doing. We'll be talking about Git strategies, different kind of Git workflows. We'll be, setting up, our repositories for each of these. We'll be putting in some, starting to put in some CI, and kind of figuring out how these things get deployed as well. But yes, let's go ahead and create these servers. So I want 3 of one size and 1 of a bigger size, just because I already know it's gonna be a problem. Shade, you can. It's gonna cost you money, just so you know. This part is not free. I don't want to tell it. I'm more so, the goal of this is more so that you can kind of see and understand. I do think it's valuable for you though to maybe try to, especially if you're on a Mac or something, I think it might be valuable for you to stick these files and try to, as we're going through installing each of them, I think it might be worth it to go through with you to try to install these things locally with me. So I'll be installing them on the server, but locally you can install these tools. You can run through the same commands. You'll end up going through the same troubleshooting steps. Or if you have a virtual box, a virtual machine, I would try installing these services inside of there, but I wouldn't necessarily tell you to go spin up some instances. Again, the goal of today is more so to understand what distributed systems are, and then to get some practice, again, doing some server management. I think you can get all that practice in without setting up an actual distributed system, but I want you to get that, start to get that muscle memory down, start to practice the commands, start to be super uncomfortable and fight through the stuff. So I don't think you need instances, or you could do it in one instance. Honestly, you can also do this on one if you really want to do it in the cloud. I say only spin up one and run through the commands and stuff with me. But I'm just showing you, I'm just showing you everything that I'm doing. So I'm gonna leave everything by default. We're not making things fancy. We're not making things fancy at all. 90 gigs, sure, whatever. I'm gonna leave the name tags off so I can do them afterwards. Now, I'm gonna wait to update these security groups after. So I'm gonna say, nope, I'm gonna give them each they're gonna have the same security group. I'll call this pipelines security group. And so we talked about this being the first line of defense. This is a virtual firewall, and the only permission it's going to give you by default is permission to be able to log in via SSH. So it has a single port open. So SSH listens over port 22. That's where it listens. Normally you can change that, but no, most people don't. And yeah, it's open for anyone. Anyone can log in as long as they have the key. So I'm going to launch it. That's the only rule it has. We'll adjust those accordingly. I already have a key. I'm going to make this pipelines is the key that we have. Okay, this is going to spin up 3 instances for me, and then I'm going to spin up 1 more. So again, the only reason I'm doing 2 different ones is because I already know that Fulcrum, to be able to even install it, takes a little more power. So I'm gonna give myself 1 medium, leave it there. It doesn't really matter. Select existing. Again, I know I'm going through things fast. The goal today is not to learn how to launch these instances. It's not. You're not even going to want to do, if you want to learn how to launch the instance, watch the horizon. If you need to learn that, watch the horizons, or go back and watch the DevOps boot camps. But that's not the, like, I really want you to focus on the goal today. So pipelines. All right. Just know that now we have 4 computers. Yeah, actually, yes, Sean from LA, you can absolutely use the instance from Horizons. If you still have it up, 100% you should use that instance. Okay, we have 4 instances here. I'm gonna give them names right now so I know I can identify them. So I'm gonna click the little thing right here. I'm gonna call this one Nginx because I'm gonna install Nginx on there. I'm gonna call this one Fulcrum. I'm gonna call this one Rocket Chat. And I'm gonna call, no, actually this one needs to be Fulcrum. And this one needs to be, what's the last piece? Blog, so Gatsby. All right, here we go. Let's do this. We're gonna put our Linux skills to the test right now. First things first. Actually, we're gonna do Rocket Chat last because it's the easiest. I'm a huge Docker fan. The learning curve is a little bit high, for sure, but the payoff is amazing. And I want to be able to contrast it a little better by struggling through the other 2. So let's go through Fulcrum first, because I think Fulcrum is probably it's not the most. It's going to be the one that we run into the most problems. Let's do this. Let's get in here. Let's get the IP address. So the same thing we did before, we're going to log into a new server. So they're already up. So I'm going to copy Fulcrum's IP address or DNS address, which is right here. Copy it, and I'm going to go and I'm going to log into it. So I'm actually going to log out of this one. All right, so I'm going to SSH-I. I'm going to tell it what key to use. What's up, Phantom Mass? What's up, Peter Yield? What's up, Crid97? Calabin. Welcome to the channel. The Chief Executive Officer is here and is following. Thank you. What's up, Raising? What's up, Privin? Cartel de Chapo. I love it. What's up, Not Plato? Victor Sood. What's up, Techie Rod? Welcome everyone to the channel. All right, so SSH-I. Pipelines is the key that I'm using. Ubuntu is the user at. All right, so you've seen the format again. The first time you try to log in, it's going to ask you whether or not you want to do this. Go ahead and click that, type in that yes. You know that you're on a different computer because now I get this prompt over here, and it gives you a little welcome message. So what's the first thing that you do whenever you get a new server or something like that? The first thing you do is you update it. There's a common practice. It's what you should do. So first thing we're going to do is sudo apt update. If you're on if you're running locally on Mac or something, you don't need to do this part. Maybe do like a brew update or something, even though we're probably not going to be using brew. So update. You can also do an upgrade. I'll do it. I might be shooting myself in the foot a little bit. 39 packages. So what update does, what that update does, you might be like, oh, what is update versus upgrade? What that update does is at first it goes out and it gets information about from all the mirrors and things that it has about what is available to it and like what it can do, what it has access to. And so that's how it lets you know that what can be upgraded, because it gets that metadata, it gets that information with the update. And then the upgrade actually updates the packages that can be upgraded. Sometimes this can take a while, but I think it should be pretty fast. Cook the Ryan, thanks so much for the gifted sub. Thank you for the support. Good to have you. How are you doing this Saturday? Finally real streaming. Excellent. All right, so there's nothing installed on the 4 servers. Yes, there's absolutely nothing installed on these 4 servers. Absolutely nothing, except for the operating system. It's kind of a base default, but yeah. So either cd into the file with the directory, or you can practice those Linux file paths. So and you can do the full you can type the path to it. So right now I'm in the directory with my pim file. Let's say I was not here, let's say I was home. The path to my pim file, I could then do ssh-i, and I can give it the full path there. So I can give it /home, mastermind, documents, AWS keys, pipelines. So again, you don't have to cd into that directory, but if you don't, you'll have to give it whatever path is necessary to get to that file, or you can just cd into the directory. Either one will work. That's a great question. So I did the update. It's going to ask you it's asking me about some if I want to keep some things around. I think that one was asking about grub. I usually just hit the default for now, since we haven't done anything in the servers. Can't really break much, so don't sweat it. Where is, that's a good question. Where is T-Bell? Now he's been around. Terrence actually been streaming during the day on his channel. We're trying to figure out a setup. He's kind of doing some more shorter bite-size programming pieces. I think he's like practicing on his channel. We're gonna figure it out. We're definitely gonna figure it out. I think he's gonna be doing some, like I said, some smaller like bite-sized courses throughout the day sometime as well. We're working on it. We're so busy right now with like everything that we're struggling to kind of get some stuff together, but it's coming. Things are coming. Okay, so we did the update and we did the upgrade. Oh, bro, well, you've been quiet. You can't be here lurking. Say what's up. You gotta say what's up to the people. You gotta participate, man. You've been here the whole time. Yes, Sean. If you use, yeah, you're probably supposed to use Ubuntu. Connection closed by. That's probably the reason. You probably gotta use Ubuntu. All right, so here we go. Here's what's next. Now we can start from scratch. So let's take a look at our repo, and let's take a look at Fulcrum, because I put the README from Fulcrum there. Fulcrum has its own open source service. So everything that's in here is basically what is there. So actually, let's actually look on Fulcrum. I probably could have picked a better looking open source application, but you know, it's fine. You know, it's no big deal. And I'll send you this. I'm pretty sure this is what I downloaded. Yeah, it seems right. You can head over here if you want. Yep, you don't have anything in the directory. It's empty. That seems right to me. Like if I do an ls here, these are all hidden. So if I just do just an ls, it's empty. There's nothing here. Remember, in Linux, hidden files are denoted with a dot. So if you do an ls-a, that -a says show me all files, even hidden files. You probably see these items here, Sean. Yeah, you add an A, you probably see some stuff. Is there such thing as a good looking open source application? Yes, there is. There are plenty of them. But there, you know, sometimes you got to fight for them a little bit. Yeah, it's definitely not prioritized. Functionality is definitely more. That's why I've been so interested, Chris Florence, in Ubuntu 20.04. That's the reason why we're using it here, is because I feel like finally, look, I actually think the reason why Linux desktop is not bigger is because like people like design, like people like what they're looking at, and functionally Linux is great. Like Linux works really well, but it's never looked all that great. Like it's, you know, and people who love Linux don't mind that so much. And you know, but everyone's always talking about, is this the year of the Linux desktop? No, it's never going to be until it looks good. And 20.04 looks good out of the box. It looks great. The icons look great. The window borders and stuff look really good. So, you know, that has always been one of my frustrations with open source applications. But again, there are plenty of them that look really, really good. So it can be done, but someone has to prioritize it. That costs money. You know, design is actually very difficult. So, all right. So head over to Fulcrum and let's figure out how to install this thing. So usually, if this is your first time diving into installing an application, an open source application or something, usually there is an installation steps in the README, or there's an installation markdown. And if we scroll down a little bit, we can see here they have a section on installation. So let's figure out if we can do that. So first things it says is we'll need Ruby on Rails installed. So Fulcrum is still a work in progress. Try to keep these instructions, get out of these instructions, but hopefully you can get up and running. We'll need Ruby on Rails. So let's figure out how to get Ruby on Rails installed. And how would you find that out? I know that I'm running Ubuntu, and I can say install Ruby on Rails Ubuntu. And my version is 18.04, but you can do this. You don't need to do anything else. You can Google it. It's okay. The first thing I did was Google. I didn't try to do anything else. I didn't, pull knowledge out of my back pocket. I Googled it. Ain't a big deal. And so we can see this here. And so we'll take a look at it. It says it'll take 30 minutes. It will not take 30 minutes. It'll take about a minute for us to do this. But first, let's see if we even have Ruby. So Ruby on Rails, I already know that Ruby on Rails is a framework for Ruby. Ruby is a programming language. It's an interpreted language for anyone who's in the decoded classes. It is an interpreted language like Python. And it is, I think it's pretty much available by default on everything. And no, it's not. So look at that. We do not even have Ruby, but luckily Linux tells us how we can install Ruby. So let's go ahead and install Ruby. We're going to use our package manager. The package manager is your friend. Sudo apt install Ruby, not Rooney, Ruby. That's what we want. So go ahead and install this. Now, we probably should have checked if there was a specific version we needed. We will learn everything that we need the hard way, because I'm actually trying to do things to run into problems, to be honest, because again, there's a lot to learn from running into problems. So does it just say we need Ruby, or does it say we need Ruby on Rails? We need Ruby on Rails. Does Ruby on Rails? I have no idea if Rails comes with Ruby. So let's read through this. Installing Ruby. So we already have Ruby installed, so we can skip this first part. This is just telling us some more ways, I think. Ooh, okay. So configuring Git, installing Rails. So it looks like Rails is installed using a Ruby gem. So gems are ways to manage packages in Ruby. So the only reason that we're having to, because of time, I'm having to give you a lot of the answers. Interesting. We don't need all this stuff, I don't think, to be honest. What happens if I type in Rails? Okay, I was just wondering. I don't remember installing Rails. Install some dependencies. Let's do what it says. It says we need all these things. Let's do it. So a little advice, or when you see something like this, generally I would advise that you install this line by line. So if you run into problems, you can more easily understand which one's having a problem, and you can figure it out. I'm going to paste them all in all at once and see what happens. And so if you paste them all in at once, it'll see those new lines as like things to go ahead and do. So it actually goes through and it runs it line by line for me. So I know a lot just happened on the screen. I did nothing but copy and paste, and now you think I'm a wizard. It makes it look like I'm a wizard. This is why Linux is fun. This is why Linux is cool. Everyone who watches this, if I was just quiet, would be like, this guy is a hacker and he's amazing at his job and he's the best. Hire him right now. And I'll be like, yep, I'm that good. I'm just that good. But all I did was copy this. I literally hit Control C and I went here and I pasted it, and a lot of magic happened. So when you see people doing a bunch of Linux stuff, a lot of times we're just copying and pasting and trusting that it works. Now, I'll say this. While you're learning Linux and you're not comfortable doing these things, I'm telling you, do things line by line. Make sure, read through and do your best to understand what's about to happen before you do it. I've been doing this for so long that I can look at this and understand exactly what's happening here. I don't necessarily know if it's going to work, but I know what it's doing. I understand what it's doing. And so I'm confident that when I plug this in, it's not going to break everything. And, I'm going to try not to give you anything that will, and we're in a safe space right now. If we break stuff, it'll be even more fun. So what did just happen? So we installed curl, which is a tool to make web requests from the command line. Then we went ahead and downloaded some packages here to kind of confirm these are keys. These are a GPG key. These are things to ensure the security and to verify the package that we're using is proper. And then this is going to add it to our source list. So this is going to make it so that we can install this package via our package manager. So it's basically going to tell our package manager, hey, here's a new place you can go to get packages. Look here when you're looking for packages. An update will just go through, and it's what we did before, and it'll update that list and tell our computer to say, hey, check these things and go see what you have available to you. And then this is going to install a bunch of core libraries that it looks like we need for Ruby on Rails, I think. I hope. So next we're going to be installing Ruby using one of the three methods. Well, I did not do it using one of these methods, but YOLO. So we already have it. So I'm gonna skip this section. And I want to get to the part where it says installing Rails. Ruby setup for development. Last step is to install bundler. Gem install bundler. We didn't do that. I didn't do that. You know what? Let's just, hey, we're living on the edge here. All right, so we get a gem install bundler. We get an error. Our first error of the day. Pretty exciting error while executing gem. File permissions error. You don't have right permissions to this directory. What do we do when we don't have right permissions to something? We try to escalate our privileges. And how do we escalate our privileges? With sudo. So we try to take on an authoritative posture here. And it's doing some stuff. I don't know anything about gems, but it says one gem installed. I don't see any errors. It seems like we have some success, and that's exciting. We need a success sound or something one day. We'll figure that out. So sure, I hope that's right. We're gonna find out if it's right in a second. So configuring Git. We don't really need to do Git right now. I think this is for some other stuff. And it looks like Rails is a gem. So we installed Ruby. And now I'm gonna try to install Rails. And again, I don't have permissions. Let's use some of our Linux foo here. When you run a command and it runs through and you run into some permissions problems, you can easily rerun that command by hitting sudo !!. This will rerun the last command that you just ran, but it will basically add prepend it with sudo. It'll escalate it so that it can rerun. So I don't need to retype it, and I can try to run it. But look at that. It failed to build gem native extension. And we get a bunch of errors here. Gem file will remain installed. Okay, I don't know why this happened, but we're about to find out. Failed to build the gem native extension. Current directory. Can't find any header files for Ruby at ruby.h. So this is great. I bet you this has to do with the way that we installed Ruby. Okay, Ruby, main installed. All right. We can check this file. Usually it'll give me a, let's see. So we got an error, and this is common. You will go to follow someone's advice, and again, we talked about the what's it called, the Dunning-Kruger effect on one of the streams this week. It's when you first start to learn something and you start to be successful at it, you have high confidence. So your confidence shoots straight up, but you don't know that much about it. So your competency is here. The amount of time you've been dealing with it, all that, your confidence is here. Your confidence shoots straight up. We just succeeded with some things that we did before this, but then we immediately run into a problem, and there's a bunch of stuff on the screen where we're like, bro, I don't even know what this says. And you start to realize the depths of your lack of information and your lack of knowledge. And your confidence goes from all the way up here, all the way down into this little dip. And as you go farther and farther, you start to believe in yourself a little bit more, you start to pick up new things. But what we just did, I was just hoping everything would go smoothly. But I want you to be cognizant of this exact issue that we're running into now. I want you to, like, you should go through, when you have time, when you're working on something, you shouldn't be running through and YOLOing it like we're YOLOing it now. You should do your best to go through and understand what you need. The first thing they say is we need to set up some prerequisites, because if not, you'll run into issues like this. And if you don't already have the like the rest of the complete knowledge to be able to work backwards or to work through a problem like this, you can really like break your brain. Like you can really struggle with stuff like this, and you might have to start over or something. So just giving you a little bit of advice while we are just kind of pacing things in. Again, this is for time's sake. Take your time. Follow what people are telling you to do. Don't skip around. It's actually, you know, it gets easier to skip around when you know a little bit more. So that just goes into that Dunning-Kruger effect thing where you're like, oh, you know, I already, you know, I got Ruby installed already with my package manager, and I can skip all this. You know, maybe you can, and maybe we can. Maybe the issue has nothing to do with where we're at now, but let's figure it out though. Let's figure it out. There's some water. Gym install Rails. Yes, that is what we did. I appreciate the bits for success, Devil 8. Thank you. Didn't know about the double exclamation. That's something that I actually learned here on the chat. I learned a lot from you all here in the chat. Someone taught me about that, and I've been using Linux for a long time, and I did not know about the sudo bang bang thing. Okay, let's see. Oh yes, this is a smooth voice. I also have a, if we ever want to get down to the you know, get some good times, I have the effects. Get ready. I can also take my voice all the way down. You know, if we ever want to get sultry on the channel, it's super nice. But you know, we'll cut it off. I don't know how to use this mixer, but I know how to use that FX button, and it's pretty fun. Why is an exclamation point a bang? I don't know why. I'm a product of the people who have taught me before, and I'm at half math. Hey, you know, if I can make your day better, I'm glad I could add to your day. Yeah, I don't know why it's bang bang. People said bang bang, and I picked it up because people taught me that's what it was. Sudo bang bang, exclamation point is a bang. I don't know. Maybe it's because in like comic books, it's like an onomatopoeia and like bang, you know, like put an exclamation, you know, I don't know. Okay, let's keep going. I'm determined to finish this. All right, so we run into a gem file error. Now, when you run into errors like this, usually it'll give you some files to take a look at. You can kind of read through some logs, and it can be pretty interesting. I actually think the problem that's happening here is that we're trying to run bundle install, I think, before we're ready to run it. So what happens is we are in the middle of installing Fulcrum, and part of Fulcrum's job is to do this bundle install. Now, if you want to know what bundle install does, Google it. Gem install bundler, bundle install. What happens is there's a gem file in here. There's a file in here that says, hey, this project needs these packages in order to run. And the bundler will go through and get all those packages installed, make it super easy for you so that you do not have to do all that stuff yourself. So I think that's what's happening. I think part of the thing that's happening here is we're not ready to do that yet in this directory. So here's what I'm gonna do really quick. First thing we're gonna do is I want this to run. I'm gonna move to a folder, to a directory. While it doesn't matter where you put this, I'm gonna cd into var. Actually, let me go to root. Sudo minus. I'm gonna cd /var or www. I'm gonna make a directory. Actually, no, I'm not. I lied to you. I'm gonna put this in my home directory. So right where you live. Oh no, I logged out. Let's log back in. In my home directory, so where there's nothing here, I'm gonna make actually I'm gonna clone this directory. So I'm gonna git clone this directory first. So on Fulcrum, let's clone it. Git clone. And yes, I want to clone it. Oh no, I cannot clone it. Really? I mean, I can fork it, I guess, but pretty sure I can clone this. Is it because it's through SSH? That's probably why. Git clone. There we go. Okay, so make sure when you click the clone or download, you have two options here. You have HTTPS, so that's the protocol of the web. You can download using that protocol, so over port 443, or SSH, but this uses the same SSH keys that we logged into our server with. This uses those same keys, so GitHub has a way for you to authenticate via those keys. Because I don't have this computer set up to do that, it would not allow me to download via SSH. So make sure you have HTTPS selected. You can just click up top here and download that one. So this is here, Fulcrum's here. So I'm gonna CD into the Fulcrum directory, and I'm gonna follow their rules now. I'm gonna try to run through what they say, and let's see what happens. I'm supposed to have Rails installed. I have no idea if I have Rails installed. Rails-v. No, I don't have Rails, but let's see what happens. Because I actually imagine that Rails is probably a part of this, a part of the gem file here. I'm like, it's got to be, because I did not install it before. And check that out. So Rails is actually a part of the gem file already. So that bundler command that we're about to run should install this. So this is a common paradigm in most languages. So most programming languages use different packages and things to support their application. They use outside third-party packages and tools and libraries and frameworks. So this will be the same thing in JavaScript. Python has it as well. The process is usually clone the repo, use whatever package manager is available to install all the dependencies, and then run the application. That's usually the paradigm. So once you kind of learn it in one or two languages, you get pretty comfortable doing it in other ones. Like I said, I'm not a huge Ruby person, but like this is the same concept that happens in JavaScript, Python. Like so Python has like requirements.txt, and JavaScript has this is like you're using npm and doing an npm install. This is like the same thing here. So I'm gonna do a bundle install now, and I bet I'm gonna run into some issues, but I think they're gonna be different issues. Wow, that was pretty fast. I did not expect to run into a problem that immediately. Your Ruby version is 2.5.1, but your gem file specified 2.2.1. Now that sounds like to me that I need to install another version of Ruby, maybe. But let's see if that's what I need to do. That's probably what I need to do. And so you can Google, how do I install different versions of Ruby or another version of Ruby. But I know that Ruby has something called Ruby Version Manager. So I'm gonna install this really quick. This says, hey, go here and learn how to install this. So it looks like I can just install this, and I'm gonna copy and paste what it says. And again, you'll see me copy and paste things that look like this over and over again, like something that adds something that runs an update, and then something that installs something. This is a package paradigm. This is whether or not you're on Yum, using Yum or apt on Ubuntu. I don't think Brew has this, but on Linux, package managers is a common paradigm. Add, basically the first thing is going to add a place to your package manager, again, to tell it where to get a package from. So a new package, it says, hey, package manager, you can go here to find new files or new packages. You update, so your computer like picks up those changes, and then you install it by name. You get bundle not found. So to get bundle to be found, you got to do gem install bundler. You got to do gem install bundler. I think we did that before. So was it gem install bundler? Yeah, this one, sudo gem install bundler will get you bundler installed. It should, at least. All right, so So I installed RVM, but I can't use RVM out of the box. Well, right now. So this is a good little example of sessions, in Linux. I installed something, but a lot happens when you first start up your computer, or you instantiate another session of bash or something. These are different running things that, like, where everything gets loaded kind of at the beginning, or a lot of things get loaded at the beginning. So sometimes when you install a new application, you cannot use it by default, because the things that have been done in the background to get it ready won't take place. It's kind of like when you need to restart your computer for something to take effect. You don't need to restart. You need to just re-log in, basically. And so I'm actually going to do that. I'm going to log out and log back in. The way that you quickly log out, you can type log out, or you can hit Control D. That'll log you out. And then the last command you probably ran was the one to get into your server. So I hit up on my arrows and I went back into the system. And now I can, in fact, type in RVM. I get something now. So let's go into Fulcrum. And let's do gem or bundle install. All right. Okay, but so it's the same error, but I never installed version 2.2.1. I think you do what? RVM install 2.2.1. That feels right. Okay. Oh, look at that. It's installing the new version for us. Now, I don't know if for Node, it's the same thing. So it's like npm install the version that you want to install, and then you can use it. I don't know if I have to use it here. I'm trying to remember what I did when I installed this. It was I ran into lots of problems. That's why I thought it was a good one to start with. So let's try now. Ooh, it's taking some time. Look at that. We installed the right version of Ruby, and now it is doing things. Again, we've reached wizard status again. And let's see, this is the spot on when this was a T2 small. This is the spot that would never pass, and so it actually would lock up the computer. So let's actually log back in and let's take a look and make sure we're not breaking our computer. All right, it's looking good. This is just to ensure that it's not locking up. I'm just kind of keeping an eye on it. So what I typed in was top. I logged into another session. So I have two tabs up here, and I just ran top. And top is just it's a interface to know what's going on with your computer. I'm not really looking at anything in particular in here besides the load up here, and just making sure things are changing to kind of confirm that the computer isn't locked up, which I think we're good, and it's moving, so we're good. I think we're good. This is where I ran into a problem the first time. This is my SQL 2 section, and there we go. And so this was an interesting one. You get a lot of errors here, and you're like, hey, what the heck is going on here? This is a lot. Look at all this crap here. Like, look at this. I remember how overwhelming little errors were for me, like one-line errors. So I understand how incredibly overwhelming all this wall of text can be. And on top of that, it even puts a bunch of red in here, which is kind of annoying. But this is a good learning opportunity to basically says to see why this extension failed to compile, please check this log. So whenever it says check this log or gives you a log, logs are amazing. Logs are your lifeblood. Go ahead and copy that. And logs are just text files. They're not anything fancy, just text. So what I'm going to do is I'm going to usually you can do a couple different things. Let's do tail. So a log spits out what happens in order. It's a log. It's a logbook of the things that happened, and usually an error will be in there. So because it does things in order, I want to look at the end of it. So I'm going to look at the last 50 lines of it with the tail command. I'm going to look at the last 50 lines and see what happened here. All right, so we got an error with MySQL. Cannot find MySQL client. So it sounds like it's looking for a package that we don't have. And again, it takes a long time to be able to interpret logs successfully. Don't sweat it. Less rather than tail. That's fair. That's completely fair. That makes sense, because then you get some of the options of moving up and down. That makes complete sense. Cool. So what this was, I spent, like I said, the first time I did this, I spent it took me like 15-20 minutes to kind of work through this problem. The problem is that it's looking for a library for my SQL client. This can be fixed in a number of different ways depending on the architecture of your computer. I think on like Macs, you can just first try installing MySQL client, and so this will not fix it on here, but this is like something you can do. So try brew install like MySQL client. And so MySQL client is just a is a tool that allows you to be able to interact with the database application MySQL. And so I can install it. This probably won't put things in the right place, but we can try it again. And the bundle install will start from where it failed, basically. It'll start from the things that aren't installed. For me, for last time, this issue had to do with where MySQL client was installed, and MySQL was installed, but the Ruby gems are looking for it in a different place. They're looking for it in a completely different place than it actually exists. So when you run into issues like this and you take a look at, the error, Google it. Google that error. Like, you could Google this whole thing, but Google does not like slashes. So Google it. So you copy this, you go right to Google and you say, man, I don't know. I have no idea what this is. Wherever it says error, find the lines that say error and look at that and like Google those. You can do both if you want, but yeah, so you can do that. So I Googled it, and you can see this was me clicking through it before. Like, bro, what's this? And so the answer ended up being, all of them are the same. All of them do a good job of explaining the situation to you. They all are basically telling you that, hey, the Ruby installer is looking for these things at a place that they don't exist. So you need to either symlink where it does exist to where it does not exist, so that the computer can find a representation of it, or the other option was to tell it how to build these things properly. So let me see if I can find the right one that I found before. So these are talking about those symlinks, but the one that I found that worked for me, that made the most sense to me. Oh no, this isn't good. Did I lose it? Let's click a bunch of them. Let's open them all up. I don't remember how to tell it to, actually I can just log into the other server because that's where I ran it, and hopefully my history is still there. These don't look good, but it was a command that basically did two things. One of them told Jim the location to look for it. And so I used that to install the individual one to make sure it worked. Actually, you know what? I think I remember it actually. No, I don't. Let's log into the other server to get it, just to save us some time. But these are usually the types of issues you'll have to work through when installing applications. Mostly it's dependency problems. So if you've ever heard people talk about dependency issues and why people hate dependency issues, and if you ever wonder why everyone talks about stuff like Docker, stuff like Docker, and why Docker is so great, is for situations exactly like this. Use Docker, problem solved, 100%. But I didn't understand when everyone was talking about, dependencies and dependency management, blah. I did not truly understand. I was like, I don't know what y'all talking about, man. Like, you gotta install stuff. Like, you gotta install you gotta install the things, like install it. But you run into issues like this, where this tutorial probably worked for the person who wrote it on their computer, because of things they already had installed. They may be working off a different base operating system. It's all pretty interesting. Actually, you know what? Let's do this too. We're having a MySQL problem. Let's see if this works. That might make it a little bit easier if it does. maybe I never even needed to do what I did. This will be pretty interesting. And if it doesn't, again, not a big deal. I know how to go fix it. Actually, while that's happening, let's actually also get logged in to, whoa, it logged me out. Let's get logged back in. I don't know why it logged me out. My session token must have expired on me. So let's get on in there. All right, pipeline start. Let's get logged in over here as well. So that finished. Let's get a bundle install going just to see. Oh, it worked. So we did run into another error, and a lot of times this happened pretty fast. A lot of times you might think that you're looking at it, the error looks the same. We have achieved a new error. I know it looks exactly the same, but check this out. It finished this. It finished the MySQL problem. We're now running into a problem with PG or PQ. I did not run into this the first time. But if we look at the same file, this new file, we can use less this time. We do in fact have a different error, and let's see what we have. libpq is no such file or directory libpq. So let's try to install this. Sudo apt install libpq. I don't know if this is a thing. I can search for it, but a lot of times packages like this are at a dash dev. Oh, look at that. That was a full guess. That was a full guess right there. Again, this is why experience matters a little bit. Don't do this. But yeah, I mean, that looks like it worked. I don't know if that'll fix it. Let's check. And I'm also running through this in a little bit of a chaotic manner. I told you in the beginning in the first class that like I wasn't going to pre-run through a lot of this stuff because, again, I think there's a lot of learning. I think most of the learning is going to come out of us struggling through problems. But again, be more methodical, be more strategic when you're going through these things. Make sure you know what you're doing. Make sure like at least what you're doing isn't going to install malware on your computer, or like, you know, don't just go trying things willy-nilly if it matters. Like if you're not in a safe space to do it, be cognizant of those things. So everything's green. Green means good. Green means go. It means do what you got to do. So Fulcrum, what else do we have to do? That's installed. Let's go back to the let's go back over here. So I did the bundle install. Let's set up this development database. So we don't want to use the development database in the future, but right now we're just trying to separate this stuff out. So let's go ahead and use that development database. Let's set it up just so we can get it running, and then we can, you know, after we get this set up, we can start to take time to understand what we need to do. So what this does is it sets up this like internal database and schema, run some migrations to set everything up so that this application can work properly. And the last thing we need to run is Rails server, and let's see if this runs. That would be nice if it did. Like I said, this is also the hardest of the three for us to install. So I'm glad we started with this first, because we were probably gonna run out of time if we did the other ones first. The other ones are pretty quick. And Nginx is also quick. Oh, so I think it's ready. So it's running on port 3000. Now, we try to run it on port 3000. We head over to the name of this, to the Fulcrum server, and we grab this DNS address. Let's copy it. I'm gonna close all this stuff to the right. I'm actually gonna close all to the right. If we paste that in, and it's running on port 3000, and we wait, and usually if you don't start to see stuff happening, you know, super the first second or two, you usually have a problem and waiting, and we're like, oh, it's so excited. Things are running, things are going, but I'm not seeing them on the front end. And you got it, tram stars and the ports. We're gonna open ports, yes. Luckily by default, most of the operating systems, I think if you choose Red Hat, you have to deal with some IP table stuff. Ubuntu has UFW turned off by default, or UFW turned off by default, which is a application firewall that exists on side of the server. But we cannot access this due to the firewall that we have set up. Again, that's called security groups. So let's go ahead and let's hop in here and let's take a look at the security group that we set up. And inbound rules, again, right now it's only allowing port 22. So we're gonna go ahead and we're gonna edit it. We're gonna say add rule for port 3000. And we're gonna say anyone can access it. So this right here is called a CIDR range or CIDR block. This is a nomenclature for you to be able to specify a block of IP addresses. So this is a number of IP addresses. 0.0.0.0/0 is any and every IP address. It's all IP addresses. So this will allow any IP address to access this over port 3000. So we want that because this is a web application. I want people to be able to access this over the web. I don't want to deal with figuring out whose IP is there and works. So now everyone try heading over to this. You're probably gonna shut the computer down, but try it out. Let's see if it works. Oh no. Oh no. Why is it? It's not working. I don't see any requests coming. Oh yeah, I do. Look at that. Is this? So these are the logs on the server, and I'm starting to get web requests for this page, but it's not loading. Oh, there we go. So we got Fulcrum up and running. Very nice. All good. That's super nice. Now, how do you run a service like this in the background? Like right now, I can't leave here because if I like Control C out of this, the application stops, and everyone who just tried to get in there, you can't get to it. There's a number of ways to run it in the background. This is the worst way. Well, this isn't the worst way, but it's a way. And so in Linux, you can run a job in the background by adding an ampersand at the end of it. And there it goes. It's running in the background now. I can still see all this stuff, but if I Control C out of this, it will not get out of the thing. If you want to see, oh darn it, I hate when this, yeah, that's the one problem with it. It'll probably keep spitting out stuff on this end. But if I want to see, I can bring it back to the foreground. And so now it's in the foreground running, which is a problem because now if I hit Control C, it's going to exit again. But we'll just run it in the background like this for now, because this is how you would probably do it if you were new. You probably like, oh no, how do I like if I Google how to run application in background Linux, it's probably going to tell me ampersands. I guess I could detach it and it'll put it in a job. If I Control Z'd it, that makes sense actually. Does it? Or does that only work with, it's already in the background. Oh. Is it still running? Jobs. Yeah, it's still running. So it's running in the background right now and it's just going, and you should still be able to access it. I don't remember what the user and group to log in was. I think it was something like test@example.com and test pass. Oh baby, we're in. Sean from LA, I like it. Yeah, go ahead and create a project with your name. I like that. There we go. That's pretty cool. Go in there, create it, have a little fun here. Have a little fun. If I install Linux on my PC, how do I open port? That is an interesting question. So your port is probably that's a tough one. If you're trying to run this locally, you shouldn't need to open it. You should be able to type in localhost 3000. If you install this locally on your computer, you should be able to type in localhost 3000 and you should be able to get to it. The other problem might be something called IP tables that's running on a lot of Linux distributions. And to turn that off, you got to do Try something like sudo service IP tables stop, maybe. Could be firewall D as well. If you're, yeah, it could be firewall D. It could be UFW as well. It's hard. What makes you think, Shrimp Stars, what makes you think that the port is not open? Also, if you do want to check if something is listening on the port, you can type in this command right here. You can type in netstat, NETSTAT -TULPN. It does not matter what order these letters are in. This is not a command. These are flags. So netstat, and then these combination of letters. You don't have to put all of them in there. And netstat is what we want. Netstat, net, not stat. Oh man, I'm struggling out here. Netstat. And so here it will show, I know, again, confusing, but there's some IP addresses here. Look for the things that are after the colon. These are ports. So port 53 is listening. Port 22 is listening. We know that's SSH. Port 3000 is listening. And it says over here, that's Ruby. That's the one we're talking about here. 3306 is listening. And then these are just the same ports, except for this one. So that's a way that you can find out if something is listening or not. If we were to stop Ruby, this would go away. This entry would go away right here. So I would just Google around a little bit to say, hey, how do I check ports? Maybe Shrimp Stars say, to get online with your local app, yeah, you should just be able to go to localhost :3000. It should be fine. You shouldn't have to open it at all. Yeah, you shouldn't have to open it at all. All right, let's keep moving along here. So we got one thing working. So let's go ahead and get logged out of here, because we have we got ourselves an up and running instance of Fulcrum. And let's make sure it's still running after we logged out. I can still get to Fulcrum, or can I? Did you overload it or did I stop it? Did we break it? Is dev down? Okay, I did not start it in the background properly then. Let's get back in there. Jobs? Oh yeah, I didn't. Okay. So the best way to run things in the background, there are, so these things are called, basically you want to turn this into something called a daemon, or turn it into a service. There's a number of ways to do it. They tell us in here how they would prefer us to do it. They don't give us a preferred method of doing this. So I'm going to run Linux, run job indefinitely, because I don't want to create a service for this right now. And I should just be able to ampersands it. Oh, double ampersands, that makes sense. No, and slash. Oh, that's a hack. We're doing it. Double ampersands and slash. That is, suppose you have a command you want to run. I don't want to run it a lot. I could have it do like a pipe it to like an and watch, but like that shouldn't have ended it though. It really shouldn't have ended it. What did we run? We ran Rails. Actually, how to run Rails. This might be a Rails specific problem. Not might be. It is. Run Rails. Perma. Oh, can you? I wonder if I can just add a D to it. Again, this is me not knowing anything about Ruby. Rails server. Actually, let's help. Let's find out if there's some options for us. Whoa, Rails help. All right, destroy. All commands can be done with -H. Server. Oh, no, -P is PID. Daemon, -D. Called it. That's experience for you, baby. Let's go. All right, Rails server -D. This will daemonize it for us. Most applications, a lot of applications that are meant to run long term come with a paradigm to do this. A lot of people think, things like this, like it is not an insignificant task to get something to run indefinitely on Linux. It was originally one of the toughest problems. Whenever you're trying to get an application Dockerized, it's usually a problem because of this. Not usually a problem, but like it takes some work up front to kind of understand how to get something to continue past its start. Because sometimes Linux will start a process and determine it is working because it started, and determine it has successfully done its job. Does this take a few seconds to come up? What's happening here? Notice server listing on all interfaces. Consider using the -- binding option. A server is already running, so that's probably a problem. Let's see. Top, actually, PS AU WX grep shift grep rails kill. Is it loading? It's not loading. I broke your previous instance. Please kill it first. Oh, gotcha. That's fine. Kill 21,623. All right. And we might have broken it completely. That's fine if we did. What's that thing called? It's called Fulcrum. My mind broke just that soon. Let's see if it runs. That looks better. That looks a lot better. We're back, baby. Let's go. We made it. So we're back and now it's running. Now I can log out of here, I hope. I'm out. Is it still loading? Excellent. Our application is running. Excellent. All right, let's get to the other two. Super fast. The fastest we ever did anything in our lives. All right, Fulcrum's done. Let's get go back again. No. Back one more. All right. Rocket Chat. Let's do Rocket Chat real quick. Rocket Chat's gonna be fun. We don't have to do any of that. While the installation of Rocket Chat does take a fair amount of setup, we're gonna be using something called Docker Compose. So all we have to do is install Docker and Docker Compose, and then we can use this file and it will install all of the dependencies, everything for us, and configure all the services for us. No problem at all. For free on Linux servers, or I need to buy that? Yes. Make a domain. Yes, you can make a domain. You can. And so, you know what? That's what we're gonna do right now instead of buying one. We're gonna make a domain for all of us. Yeah. So there's a paradigm called there's something called a host file on your computer, and the way that computers know the internet operates over IP addresses, so numbers, so 0.0.0.0 or 127.0.0.1 or 54.162.116.136. That is the address, just like your street address. That is how computers know where to go to get the data that they need. The way that your computer knows what numbers to go to get that information is through something called DNS. So when you type google.com into your browser, a protocol happens, and your computer makes some requests, and it actually goes and gets the translation. It actually says, hey, I want google.com. What is the address for google.com? It's like looking it up in the phone book. And it goes in and it looks at, like, it gets a response and it says, all right, cool. Google's at 5.6.7.8. And your computer then goes out to there to grab what it needs. A host file will allow you to override that and to mimic what DNS does. And so, like, I could actually right here on my local computer, I can actually tell my computer whenever I type in fulcrum.ourcompany.com to go here, and I can tell my computer to do that. And we'll do that at the end. That'll be the last thing because it's not essential, but we will we'll simulate that if we can. All right, next piece is Docker. Let's do a little Docker stuff. Show you why Docker is great. Rocket Chat. I don't even need to go to the Rocket Chat website. All I need to do is install Docker. So I'm gonna log into that server first. The server that I want to log into is What's up, Geraldo Sales? What's up, Tizboyo? I need to scroll to the top a lot. These might be older people. Oh, I'm way down. What's up, Luke? Luke, Mr. GZ. What's up, Alex? How you doing? What's up? What's up, Mr. Tonight? Welcome to the channel. What's up, Casual Freddy? What's up, Myris? Cut the Ox. How you doing? What's up, CH Prawn? How you doing, Neuro? What's up, everyone? Good to have you. Glad to have you around. Okay, Rocket Chat. Let's get Rocket Chat installed. Let's log in. Let's practice our tools. How do you get into a server? You SSH into a Linux server, and this is key-based pipelines, Ubuntu, paste it in. Let's go. First time we're logging in, got to type in yes. All right, first things first, what do you do when you first have a new server? Sudo apt update. Should be pretty quick. We're not gonna upgrade, we're just gonna update to kind of get moving pretty fast. Is this AWS account paid, or are you paying those instances in order to show us stuff? I'm paying for these instances to show you stuff. Yeah, I'm paying for you got, like, everyone's been super kind here. I gifting subs and stuff, like I'm paying for them. I'm trying to work, I'm trying to get some credits from AWS, but right now I'm just paying for them. I'm gonna shut them down. So it's not going to cost me much. I'm going to shut them down every week and start them back up. But once we get to automating these things, once we get some Terraform set up, I'm actually going to destroy them every day. Every time I'm going to destroy everything and spin it back up at the beginning, so you guys can see how powerful something like that is. All right, let's see. So upgraded. The way that we install Docker, you can go to Docker's website to figure this out. I'm going to use the package manager. Even though this is not the preferred method, this is the fastest. Oh no. Are we out? What happened? Did the stream die for anyone? Wait, it died for me? Okay, yeah, okay, cool. I just refreshed and it's working now on my end again. All right, so we're gonna install Docker. So we're gonna do sudo apt install docker.io. If you're on like your Mac, I think you should just go to Docker's website and download the Docker for desktop. There's like a little click-through installer. But again, like I said, this is not normally the way that I would install Docker, but it's the way that we're gonna do it today for speed's sake. Why isn't this the way that I would install Docker? Okay. These package managers manage packages for you, so it makes it easy for you to install applications. The problem is that means someone is maintaining what is the most up-to-date thing there. Like when a company puts out a new package, it doesn't mean the package manager automatically gets the new stuff. That has to be pulled in. So package managers don't always keep the latest and greatest. Sometimes it makes it hard to get the versions that you need. So for Docker, I do recommend installing it from Docker's website, running through the installer, how they tell you to install it. But again, this will serve our purposes today. Now, we have Docker installed. The way that we can confirm, sudo docker ps, same as Docker even running, sudo docker service docker start. I gotta tell you guys one thing is, I'm an old school Linux person. Failed. No problem. Sudo, I'm gonna go root. I'm an old school Linux person, and something I still struggle with to this day is I'm an old sysv user. So usually I'm used to starting services like this. init.d docker start. This is how I'm used to starting services. But that's not the way. This is not the way. Really is systemctl, and the problem is I never remember the order of what is right, because you can use service or systemctl. But why I installed Docker? What happened when it installed? I wasn't paying attention. What's happening? Scroll down. There we go. Sudo apt install docker.io. what happened when I just tried this? So Docker PS, connect to Docker daemon. Is Docker running? Oh, it's probably got, I probably need to install Docker. I need to start, what's the name? Service. Docker, yeah. Status. Stopped. Queue. Start. Fail to start mask. The Vim unit Docker status. Hold on, let's see. Running as sudo backwards. I'll add the Docker user group. Yeah, I can do that. I don't think that's the problem yet. Is the user group permissions yet? I think it's actually well, I think this is I'm on Ubuntu 18.04 for this. Yeah, I'm on 18.04. This works. Hold on, let me see. Install Docker Ubuntu 18.04. There we go. Install Docker engine. So DigitalOcean has really good documentation. I use them for a lot, even though I don't use DigitalOcean stuff. They're really good documentation for stuff like this. Update. So they're doing it the real way. I really just wanted to install it using, feeling lazy, but this is what happens when you cut corners. Nope, this is the real Docker way. All right, we'll not use okay, it's pretty simple. It's not a lot of stuff. It's just I'm trying to be lazy, so I'm actually going to remove it. Sudo apt remove docker.io. You got to spell things right. Linux is not only case sensitive, but word sensitive. Like, you got to be spot on. All right, so I removed that package. Let's add the Docker repos. And see, people make it nice for you. You can just copy and paste. Nobody in the whole world, nobody is better than me at copy and pasting. No one. Challenge me and see what will happen. I got copy and paste. I was born for this. I was born to copy and paste. I'm so good at it. Look at this. Have you ever seen anyone copy and paste so smooth, so delicately, yet so authoritatively? Look at this. Oh, look at this. I even know the prompts before they hit. I'm like, oh yeah, here it comes. I've done this so many times. I don't know what it's doing, but I can copy and paste it. Come on. See, I work even faster than the computer does. People say computers are fast, but no one's a faster or better copy and paster than me. And I'll stand by that until the end of my days. And Docker's now running. Look at that, active. I don't even care about the rest of the text. I look for green, I look for red, and that's what matters. And green says running, so we're good to go. That's very exciting. I can confirm this by doing a Docker PS. And there we go. That looks good here. Nothing here. I have nothing running, but I have Docker. Second thing, this is much easier, is we're using Docker Compose. So install Docker Compose. All right, Docker Compose is just a one install script. I know it's tiny, but it is a copy and paste job. And again, you know what I'm good at. You know what I'm good at. It is copying and pasting. We'll copy it. We'll paste it. Oh yeah. Then we got to make it executable. So all this does is this downloads a script for us. That's going to set up it's going to download the Docker Compose binary for us. And then we just got to make that thing executable. And now check this out. Docker-compose will now give us some stuff. Now, what I'm going to do is right here, I'm going to make a directory. What's the name of our application we're doing here? Rocket Chat. CD Rocket Chat. All right, and every Docker Compose must be served out of a docker-compose.yaml. And so we're gonna Vim one, head over here and copy and paste this bad boy. All right, I'm gonna paste it in. We got a whole file here with all of our stuff that we need. I don't even care what it says. You don't, I mean, right now, we'll dive deeper into Docker, and we'll actually be Dockerizing some applications throughout this course, like learning how to approach Dockerization from scratch. Even though a lot of the times the Docker containers that you already need are going to be built, there's a lot of times, a lot of scenarios in which you cannot use those for security reasons. Mostly it's because of security reasons. It's common practice to build them yourself so you know what's in them. So all we got to do to run this is do a docker dash compose up, and Docker is going to take care of downloading everything for us. Oh, you all right? Oh no, you good. I just want to make sure you're okay. Had to check on the dog and check on the wifey. Yeah, we can't see her. Maya, come here, girl. Is she up here with you? Come here, girl. We'll see if she comes upstairs. We'll get some eyes on her for sure. Yep, there she goes. This is the doggo. Let's see. She's right. Look, hey, Maya, don't. Well, she's under the table now. I'll try to move this in a little bit. She there she goes. There she goes. A little bit off camera. She's a good girl. I said she's sick. I don't mean to be a Debbie Downer, but people have asked me about her. She does. It's a common in Rottweiler. She does have bone cancer in her right leg. So tough break. But you know, they told us in the beginning that usually this is like a 5 to 6 month thing, but she got diagnosed with it like right after Christmas. And she's doing good. She's still doing pretty good. We're just keeping her happy, she's having a good time. She's lost a little bit of her mobility, so we've just been going for rides and stuff, but she's like I said, she's still happy, she's still having fun, but she's good. You'll hear her barking. She's probably barking at nice people walking down the street. She's actually very friendly, but she's got this thing about being behind glass. I'll have to clip it for you guys on YouTube. The office that we work out of, everything's glass, and even with people she knows, even like us, she will bark at us like through glass, and it's really crazy. Like she actually acts really wild, but then you open it and she's like the nicest dog ever. So no need to be scared of her. She does, yeah. So she does have hip dysplasia. She got diagnosed with dysplasia right at her first birthday. She's almost 8, I think she'll be 8 on June or July 1st. So you know, she's lived with it for a long time, but hers has been pretty minor in comparison to a lot of other dogs. She's been able to, you know, run around and have fun, but if she runs around too much, it'll start to bother her. But she's also lazy. Like even before she got dysplasia, when she was like 6 months old, like we tried to get her to play a lot, and she doesn't like the heat. Only dog in the world, like if it's summertime, it's easy to take her on walks because we'll be outside for 2 minutes and she's like, yeah, you know, that's a lot of sun and it's making me warm, and I think it's time to go sit in the air conditioner. So it's been pretty interesting. But check this out. Look at all the just stuff that's happening. I ran one command and Docker went through, is now installing everything, but it's also spinning up the application. These are just all the underlying logs. I know it looks like it's doing a lot, but it's just spitting out some information for us. This only happens the first time. Like there's a lot happening. And what's happening is I'm pretty sure that all of the services are just going up and down because they're waiting for each other to kind of start up and get ready. I don't know if I'm set up to, I should be set up to run this properly. Yeah, okay. So stop there. I should have ran this in the background. So once we finish this, we should have multiple instances. You can have them on the same server. Yes, we will have multiple instances here. You absolutely, like I said, can have run these on the same server. And so yours wouldn't be really a decentralized or distributed, but like but you learned how to install some stuff, which is nice. All right, is this up? Error. If joining in general, please make sure it's. Oh, I wonder, are you guys in this? Is that what's happening? Let's see. So let's go here. This is also running on port 3000, I believe, and this has the same security group. So we actually don't need to open up anything because I gave these all the same security group. So if you hit this 3000, yeah, look at that. Rocket Chat is up. And I could set up everything. I haven't set up anything, but Rocket Chat is there. So I could type in everything that I needed, but we'll leave that up. So Rocket Chat is available. You can hit here. Let me set up the admin stuff first, just so I can at least get back in here. Just so I can at least log in. Can you see the password? You can't see the password. That's good. I mean, if not, I'll just shut it down and lock you out and then start up a new one. It's not that serious, but yeah, let's see what happens. How is Docker different from, say, a gem file? Great question. So that's a really good question, actually, Shade. So the difference between Docker and a gem file. So while they're both used to handle dependencies, a gem file would actually be used inside of Docker. The Docker is the method of packaging it all up, and also the method of running it. It's also the runtime itself. So you wouldn't use one over the other. To build this, when we do Dockerize this, we will have to basically do in the Docker file that we write, we'll basically have to implement all the things that we did manually. We'll have to implement that in the Docker file. And so what that'll do is it'll basically take all the tasks necessary to run this and package it. It's less like a script and more like it saves the final state rather than like a script. We could scriptify all that and it would run through and it would try to install all that stuff real time. The problem is things change over time. So the output of a Docker file is actually the image that has everything rather than just the code that's needed to pull everything in that we need. And also, again, it's a method of isolated runtimes. So yes, it's not, it's they're both used to manage dependencies, but you would use a gem file in a Docker file for a Ruby application to get all the stuff. Like you would actually do a bundler install inside of your Docker file. Like if we look at some Docker files, they look like bash scripts. They really are like bash scripts. Yeah, it's a VM without the overhead. You can think about it like that. It's not a VM, but well, it's a type of virtualization, but it's not a VM. But yeah, without the overhead, because the reason it doesn't have the overhead is because a VM, you have to install an entire operating system in a VM. So if I have Windows on my computer, I install a VM, I got to install Linux on there, or I got to install Windows on there, whatever. Containers are tiny, or they're a lot smaller because you don't need a host operating system. They all, it has APIs and stuff for the container to actually interface with the host system kernel directly, rather than, have to install an entire kernel inside of a host machine there. So we'll go over some more container stuff for sure. Organization name, mastermind, industry, advocacy, whatever, 1 to 10, country, worldwide, website, mastermind.io. Server type, public community, that's fine. Yes. Site name, mastermind.io. Sure, agree. I don't know if you can sign up for this. You probably can. So yeah, so if you go here, you can probably get there. Docker is on top of the OS, correct. Docker is, it's an application installed in the OS, and it's not a hypervisor. It is not a hypervisor at all, but yes, so much faster put out. That's great information there. So maybe you can log into this. I don't know if you can log into that, but we do have this running. And again, we also still have Fulcrum running on completely different services, different servers. And let's also do the last one, which is Gatsby. So this one's gonna be a little more simple. For what we're gonna do for Gatsby, let's log into that server really quick. Let's get so actually now you can't get in, and if you're trying to get in, I'm sorry, I broke it for you. We can also daemonize this. So when I stop this, it's actually going to turn off all those containers right now. So there are actually 3 containers that make up this one application. And so again, just to kind of highlight the distributed nature of computing, Hubot is one. I don't really know what Hubot is, but Rocket Chat is one, and MongoDB is the other. In a distributed system, I could take Rocket Chat, the application, put that on one server. I could move Mongo to another server. So the way that they would speak to each other would be over the network rather than locally. So I'd have to modify some connection strings and things. But this server, to get information, the Rocket Chat server would go over here to talk to the MongoDB server and all that stuff. But to you on the front end, to you the person using Rocket Chat, you wouldn't know the difference. You wouldn't know that there were multiple backend pieces that were distributed in different locations on different machines that were making up your experience. And most things you're touching are like that. So it's a pretty on the nose concept. Like the word says exactly what it is. So a lot of what we're doing right now, just because we're not going to have time to move, my goal was to move Mongo off of here. We'll do that in the future. We're not going to have time today at all to move that off. We're more so decentralizing our applications, because all these applications are the reason why it's not so much distributing them is because none of these are dependent upon each other. They're kind of 3 different applications, which we are separating. So again, we are decentralizing them, and decentralization is a form of distributed computing, but not necessarily the concept I really wanted to show. I thought we were gonna get to the part where I could, but no big deal. So this is running in the background, so we're good here. And the last one, let's go ahead and get the last one, or last 2 real quick. Gatsby, we're gonna run, let's log in here. Just gonna change the place we're logging into. First time we're logging in, yes. What do we do first? Sudo apt update, and we are updating. All right, so updated. So Gatsby is a Node React tool. It needs Node, it needs npm. So I'm gonna install those really quick. And so we could actually go to the Node, let's see, Gatsby JS, if you want to follow along. Oh, this is what I grabbed, the starter site. I didn't grab the Square starter. I grabbed, in fact, I'll send you exactly where I grabbed this one. And you can take this if you want. If you ever want to try this, is there a special way to stop daemonized processes? Great question. That's a great question. Yes. Special way? No. There's a number of ways to do it, actually. One way you would do it is, what am I logging to over here? You can do it in a few different ways. One is using your PS command, which is a command to find out what processes are running on your computer. So if I do PS AUWX, you get all the processes that are running. I can look for, again, this is the Linux food. This is what takes time to learn. I can grep for Docker because I'm running Docker Compose. So Docker didn't show up. I might be on a different service. I actually don't know which service this is. Oh, this is Fulcrum. So Fulcrum is actually running Ruby. So I can check for Ruby instead. And I can see that this is the task that's running. It's running Rails server-d. That's the command. And I could kill this process if I wanted to do it. There's probably a Rails command I could run to stop it as well. But yeah, every daemon is going to have something different. Let's see. So you can follow this if you want. So let's follow this. Prerequisites are that you again have Node.js and npm installed. So I'm gonna do I'm actually gonna do all that through nvm. So just like we did RVM for Ruby, which was Ruby version manager, there is a node version manager. So install nvm. And the reason I'm going to do it through here is because Ubuntu in particular has permissions issues that you can run into when you install node via the package manager. So I'm just going to take this. I'm going to do what I do best, which is copy and paste. And actually I'm in the right place. Copy and paste. Let's do this. Come say hi. Oh, you sure? Come say hi. This is my bae. It's my wife. She brought me water because she's super kind. I didn't even ask. Oh, true. And now that's my pup barking. She doesn't like, it's weird because the dog, she doesn't like when we're not in the, like, she wants us to be in the same room together. And like she'll want, like if I stay in the room doing work in the evening or something, and like my wife goes to bed or something, like the dog will come whine and bark at me to like come in the room. But she also doesn't like when we sit too close to each other. She like breaks us up. Like she like, it's like, yeah, I want you in the same room, but like mostly so y'all can give me attention. And it's like, bro, you gotta relax. You gotta relax. All right. What did I just do? Did I just install NVM? Did it work? Yes, it did. And I need to log back out and log back in to get it, or I can source my profile, but I'll just log out and log back in, and I have NVM. And so now I can use NVM to actually install what I need. So I'm going to do NVM install latest. So again, this is Node version manager. So this is going to install the latest version of Node. Sorry, not latest. Whoa, excuse me. That was gross. LTS. That water messed me up. But it's not LTS. I thought it was. The dash LTS. NVM install LTS. Wow, that was not spelled correctly. There we go. So it's going to install the latest version of Node for me. This also gives me npm, I believe, by default. So now I can install the things that I need. What I need to do to install Gatsby is I need to install Gatsby first, which I think I do via npm. So install Gatsby JS. Quick start. Npm install -g Gatsby -CLI. That's what we're gonna need. What's up, No Diggity? Welcome to the channel. Good to have you. We're almost done. What's up, GR360R? What's up, Zrayla? Bavance, Bavins. That man, Bovice? Yeah, I'll try that. Let me try it one more time. Bav Weiss. Welcome. GD Mikey, how you doing? Fred is not dead. I'm glad Fred's not dead. I'm glad Fred's alive. What's up, Jess? How's everyone doing on this beautiful day? All right, we are finishing up what we're doing here. So that installed, we installed Gatsby. Gatsby new. I'm just gonna run the command they have here. And that's gonna run it. So the interesting thing about Gatsby is two things. I can actually run it as a server if I want, but that is not the way it's intended to be used. It just uses some basic files. So actually what we're gonna do is we are not gonna install a separate Nginx server. We're not gonna install a separate Nginx server. We are going to install Nginx right here. So that I don't have to install two Nginx servers. Do we need Apache 2? Great question. You could use Apache 2 in this instance. We could use Apache here, and then do a separate Nginx installation to proxy to the things. But you can use Apache if you like. It doesn't proxy as well. It's harder. But you could use it if you'd like. We're going to be using Nginx instead. Which works a little bit better for the microservice distributed nature of things that we're about to do. And actually, while this is installing, let's go ahead and let's like log in and do everything kind of at once. And it'll be confusing, but again, the goal is not to know how to do it. The goal is to kind of get some context around doing it, but understanding, the concepts of it. And, today is more so about practicing some of your Linux foo, getting applications installed, just getting comfortable, just getting a little more comfortable, and a little less afraid of the big commands and the big words and running things, and just it's getting comfortable. What's up, Larry? How you doing? What's up, Illuminated Space? Welcome to the channel. Why would you install Nginx separately? Great question. Great question. Let's here we go. Let's see if the whiteboard is working today. It picks and chooses when it wants to work, to be 100% honest. Sometimes like the what's that thing called? The resolution is off. Like now, the resolution is in fact off, but it's a great opportunity. Real quick, this is something we did before. Maybe I'll save this. Actually, let me just open up a new page. Scroll back down. What? Go away. Plus, I don't know what I'm doing, so I'm gonna delete this. All right, so quick. This is the reason why we would use Nginx. We have a server here, a server here, and a server here. This one has Gatsby. This one has the one that starts with an F, Fulcrum. I'm never gonna remember that. And this one has I was gonna draw a rocket, but that was gonna look like a wiener, so I'm not gonna draw a rocket. I've learned my lesson with the internet. Oh, is this almost dead? Oh no. No, it's at 100%. Why can't I use my eraser? Yeah, it was definitely gonna, what? I don't know what's happening here. All right, it was definitely gonna look like a wiener, so we're not gonna do it that way. I don't know what I'm doing. And this one was rocket. This is not my normal chat. This is not my normal app, I think. So rocket chat. So here's the thing. This is running on port 3000, which is super annoying. This is running on port 3000, which is super annoying. Actually, no, this one is. This is not running on a port at all. This is just web file, so this is actually on port 80. 3000. But you don't want to have to type in :3000 every time you get somewhere. And because this is not running, this is just static site files, it needs a way to serve it. It's not an application, it's just files that are sitting somewhere. Let's say we owned a domain which was pipelines.com. Sure, that might be, don't go to that website, that could be anything. And so maybe we wanted to get to Gatsby off from blog.pipelines.com. Ignore my writing, I don't write often. Maybe we want to get to Fulcrum off of project management, whatever. And maybe we want to get to Rocket Chat off of chat.pipelines.com. We can go through one source to be able to do that, to be able to proxy back to certain applications. And it also will allow us to, it gives us some flexibility among for different forms of load balancing. It gives us some flexibility on moving things around. It gives us some flexibility on how these interact with each other as well, and how they speak to each other. It also gives us, again, the biggest reason we want to do this is it gives us a way to access these without having to put in :3000 is like the number one reason. But yes, but so the way we do this is we actually set up a Nginx server to be a proxy. So all the traffic goes into here and then it gets sent to where it needs to go to. Nginx versus traffic is used for microservices, for more container, like microservices architecture. It's pretty interesting. But yeah, it's traffic's cool. I like traffic, especially because it's built in Go, and I love, how do you spell traffic? It's spelled funny. Was it traffic? It's like it's like, that could be way wrong. Yeah, this one, traffic, the cloud native edge router. So like traffic is heavily used in like Kubernetes and stuff. that works, you know, a little bit differently. All right, Nginx was for Node. No, Nginx is not. Nginx is a web server. All right, here we go. Real quick, let's move. So Gatsby's installed. I'm gonna run a Gatsby build. So it's gonna build our site. Gatsby build. And when Gatsby goes through the builds, either the current working directory, am I where I need to be? Am I in the wrong server? What is this? What is all this stuff? I don't know what all this stuff. Oh, I gotta go into Gatsby goes. There we go. Gatsby build. This is gonna build our site for us. I'm gonna let it do that. And while it's doing that, I'm gonna relog into here. And I am going to set up Nginx real fast. It's gonna be the fastest Nginx setup you've ever seen in your life. Same server. Let's get logged in. Let's go. We're gonna finish so fast. We're already a minute over. Here we go. Nginx is a super easy install. Sudo apt install Nginx. The fastest. That took long. I sized it. I hyped it, and then it took like a little bit of time. That's my bad. I was like, you know, my brain was moving real fast, and then this happened, and now it's taking forever. It's really still in my speed thunder. Come on, Nginx. It's most likely because of this though, because this is taking a lot of time. Yeah, I'm probably overloading this a little bit, but it'll be fine. Whoa, man, I need to look at the chat more. Somebody tweet him. Well, there we go. I was in the zone trying to finish up so you guys could get out of here by like now. Also, today's an exciting day. One of my coworkers, he like grills and smokes meats, and he's brought in some like ribs and stuff before. It's been amazing, but he's selling some plates today that I'm going to get, and like I'm really excited for some good barbecue. I'm going to pick it up. So it's gonna be. I'm pretty hype about it. Pretty hype about it. We'll be hitting it. I'll be hitting that up like a 3. Going to get some good food and bringing it home and gonna enjoy it. All right, you guys didn't miss much at all. All I did to install Nginx was sudo apt install Nginx, and it looks like it's gonna fail, or like it's taking a long time. But I think it's taking a long time because Gatsby is building and taking up probably all the processes on the computer. So I'll stop this so that Gatsby builds faster. And so remember, like I said, static site generation, this is all extra stuff. This has nothing to do with distributed systems, but this is great to know on your journey. Server side rendering or static site generation is, again, doing all the work up front, having the server generate all the possible pages and things that would exist on your site, and turning them into Markdown or HTML or whatever it's supposed to be, so that you have you don't have a backend server that's doing much or anything at all, and you can just toast those files. So all these files are now in this public directory. So if I had this locally, I could just click on this index.html here. I can just click on it and it will work. The whole site will work. I would not need a server. But let's go ahead and install Nginx. That's how you install Nginx. It's installed. It's already running most likely. So take this address. Check that out. Click on that. See if a basic Nginx page loads up for you. It might not. It should though. Let's see if Nginx is running. Nginx status. Yeah, it should be running. Oh, but this has a different wait, what does this have a different? No. 480 should be working. It should be open. Oh, it's not. Oh, okay. We never did 80. You're right. Thank you. So port 80 is what we need. Open it up to everyone. Thank you for that. Was our port open? No, but now it is. Now this bad boy is open, I think. And try refreshing. It's still not. It's not working. Come on, fix yourself. Let's see. What's up, Mafioso from Belgium? How you doing? All right, so it's working. This is the page that you're gonna get. You want to see some magic? You want to see some real magic? Take a look at what you're looking at right now. Oh yes, make sure you don't type in HTTPS. You're right. So I think when you click on it, it might add it automatically. Let me type it in as is. It's really annoying when it does that. Try that one. The new link. Because it's not being served over, see, it says it's not secure. It's not being served over HTTPS. Your browser probably is going to try to add it automatically to keep you safe. But I'm not trying to hurt you. I promise you. All right, so watch this. We want to get our Gatsby site up. Check out this. I'm going to take everything from here. Copy -r dot. I'm going to copy this to var www HTML. Oh, whoops. Oh, wait, sudo. Refresh that bad boy. Let's go, refresh it, see what you get. Uh-oh, did you get a Gatsby demo page? Yes, you did. All we did was copy some files over, and the site that it generated is now here. So this is, on our server, and we can change some stuff in it to make sure people know that it's ours and not just a demo site. But right now, that's not important. We just want to get it running. So there we go. You say anything about Rickrolling? I should have. That's Rickrolls are coming then. Now, like, you shouldn't have brought that up. So we have our blog site up. We have Nginx running now. So this is great. Nginx is running from here. But what we can do is we can also set up, what's that thing called? Nginx reverse proxy. So what we can do is we can tell Nginx to listen for some things. Let me see. Those are good examples, but I'm trying to see if there's a more a simpler, bigger answer that shows like one clean block. So web servers are interesting. They're highly configurable, and so basically you can use it to route traffic. So web servers, all they do is they respond to traffic over web ports, and using web protocols. They understand how to use those things properly. cd/etc nginx. So right now there's some stuff set up, and right now everything that you see is sites available default. Basically by default when things come in over port 80, so remember, this is how it knows what port to listen on. We could change that port and it could listen on a different port, but it's listening over port 80 because that's the default port. It's saying, hey, whenever you get a request over here on port 80, head over to var www HTML, and so there's just some files in there, and so basically what's happening is it's serving an index.html that is in this directory. That's why I copied all those files over. And so great, it does some simple stuff. Everything that's in blue with the hashtag in front is a comment, so none of that is enabled. This is actually a pretty small configuration. It's only like 8 lines of code, actually. But what you can do is you can modify configurations like this to be able to pipe in between all of them. But I think that we're actually not going to do that now. Now that I'm thinking about it, I think our time might be better served doing that, actually implementing that piece when we start to use them together. So maybe we'll hold off on that, one, for both time reasons, and I think there might be a better spot for it. So what did we do today, and what do we make sure we focused on? So today we learned about distributed systems. We learned that distributed systems are simply a way to take distributed computing resources and put pieces of an application on and distribute the pieces of an application amongst those servers, so that the end user's experience can feel like it's from a single computer. So it's breaking up that computing experience is breaking up the resources and the tools necessary for an application to work into different places. What does that get you? Why would you do that? You would do that because it provides you some fault tolerance. So it allows you to, it allows pieces and parts of your application to, because they're independent, allows some of them to fail and for your application to still work, or many parts of your application still work. It doesn't bring down the whole thing. If one piece dies, other things can stay up. That's the first big thing. The second big thing that you get out of that is ease of scalability. Yeah, ease of scalability. So when you break these things up into different pieces, it makes it a lot easier to make sure that your services and servers and pieces can respond to demand that comes to them. Why? Because the pieces of them are a lot smaller, which means they can be provisioned much faster, and they can be provisioned independently. It makes that that situation a lot easier. The third thing, what is the third thing? Sorry, let's go back. Third thing was performance. Yes, it makes it, it can make it much faster. It can make it much faster for a lot of reasons. Again, if you put a bunch of stuff on one server, resources on a computer are limited. Breaking it up like this can allow for each independent piece to be optimized for what it's doing, and performance can be blazingly fast in distributed systems if done right. But there are some trade-offs for distributed systems, as with every technical solution or implementation. One is one of the biggest ones. One of the difficulties when setting up distributed systems is network failure. You are increasing your network footprint exponentially by doing this, and network failure can be a big issue. Latency as well. The time it takes for data to transfer between services can be a big deal. It can slow your user's experience down if not done properly. But again, the cloud was kind of designed for this, was designed for distributed computing. So normally there are solutions for this, but it is something to be concerned about for sure, especially if you have maybe, your front end sitting close to people. Maybe all your clients are in Australia, but your database is here in America because your your client maybe there's some data sovereignty rules that say, hey, that data that you're storing has to be held on American soil. And so think about the amount of time it takes for data to get from Australia to America and back. While not incredibly long in the grand scheme of things, it can be on magnitudes of 100 times longer, even though it's still pretty fast. Observability, it's hard to know what's going on. It's hard to set up a situation where you can understand what's happening in your system with all the different pieces. So making sure you can set that up properly is a difficulty. And then management and overhead, it is there's definitely a cognitive load, a significant increase in cognitive load associated with managing distributed systems, different pieces like this that operate completely differently, that operate in isolation. You kind of got to know how they work. You got to also know how they fit into the pie, how they fit into the puzzle. So that can be pretty interesting. We learned about some of the different types as well. Take a look at those. It's good information to know and to think about later. But what we also did is we dived into mostly Linux stuff tonight. We dived through the roadmap a little bit. We just ran a lot of Linux commands. We learned how to do the OS management. We learned how to install applications, and yeah, we copied and pasted super quickly. But we got to see some errors, and we got to look at how you might look at some errors. I don't know. We just got more familiar with this stuff. We didn't get to spend a lot of time doing deep stuff with Linux the first time, or doing OS concepts. So we'll be doing this the whole time, but this was a good dive into just trying to trying out these things and starting to put these concepts into practice. I think what I've seen so far is with people trying to get into DevOps and SRE stuff recently is that because there are so many tools that help you with some of the other stuff, people miss out on understanding these, and it really makes their time tough. Like they don't really realize they're like, oh, like why can't I just do this through Terraform? And it's like, you can just do it through Terraform, but to do it through Terraform, you have to understand the underlying way that this is implemented so that you can put it in the bounds of Terraform. And so that's been pretty interesting. So I'm glad we could dive into some of that a bit. Yeah, and we'll be doing some more of that. We are going to get into this reverse proxying stuff a little bit more. But we're going to move through all of it. We learned a little bit about Nginx and some of the web server stuff. But yeah, we just got some stuff ready. You learned a little bit about Ruby and Ruby on Rails. You learned a little bit about JavaScript, all of the many things that you're gonna need on the job, just because DevOps and SRE is like, you're supposed to know the whole framework and pipeline, and it's just a million tools. It's a million tools, and yeah, that was a lot. Today was a lot, and we got through. We didn't quite get through as much as I wanted to, but what we do have coming up, and I'm actually going to also take this, like I said in the beginning, this would be an experiment. This course in particular would be an experiment because we've never done an intermediate course, and we've also never done 1 day a week courses. So this is going to give me some insight on how to approach next week. But again, the thing that we're going over is the stuff I hate the flow of GitHub and how you get to where you need to be. Maybe I just don't know where I'm going. But next week we're gonna be diving into we're gonna be taking these things. The first thing we'll do is we will get Nginx and their reverse proxy installed. We'll get that installed. But we will be taking these repositories and we'll get them into a state that we can manage them in Git and GitHub, and to kind of understand what we need. We'll be talking about git ignore files. We'll be talking about just kind of different version control concepts. This is very important. This is very important for creating pipelines, like understanding code strategy, version and source control strategy is going to be important here. We're going to learn about a lot of different ways of doing it. We're going to practice some of it as well. We'll all try to commit to some repos and see how those overlaps happen and how we can mitigate those as well. And that'll lead right into the CI/CD stuff, so we can actually start building these pipelines, so that when we want to make an update to our blog, we're working at this company that's bringing on a lot of people. We're getting new developers. Being able to set up development environments, things for these new devs is going to be an interesting paradigm. So that's it. That's everything we got. What's up, Callow? Appreciate the tier 1 sub, the gifted sub, Callow. Thank you so much for the support. And for everyone who doesn't know, Callow he's also a streamer. I try to shout out streamers when they come across that I find both interesting and that you can learn from. So yeah, Callow he's pretty dope. Check him out. Definitely check him out. I'll always give the shout outs when people come through. Yes, pipelines is every Saturday morning. We will not be using Jenkins, the ego. We'll be using we might keep it in-house. We'll vote on that. We'll actually, again, I'm not pre-planning a bunch of this. I don't think the CI tool really matters, but we are not using Jenkins. We will either use GitHub Actions, Travis CI, or Circle CI. For one of those. We'll use one of those. It might be fun to use GitHub Actions because we're in GitHub, but we could use GitLab. I'm not super opposed to it. I'll put it on the list to vote for. Homework, great question. I have homework for you. I'm gonna post it in the Google Classroom. The homework is there's no actually, for this course, there's actually no there's one actual do this homework assignment. There's a quiz this week. There will be a quiz going up today. It's a lot of questions. It's like 35 questions. There's a quiz going up today for this, and really the homework is just a bunch of resources to cover different structural paradigms. So there's some stuff in there about distributed computing. There's information on there about we'll cover monoliths and monorepos later, and microservices, but there's information about monoliths and their benefits as well, because I do want you to understand that as well. Even though we're doing distributed computing, a lot of people are moving from monoliths to distributed networking and distributed computing, and that's what people are kind of getting hired for. So that's why we focused on this. I'll give you information about monorepos in there as well. There's a few other things. Yes, there is. It sounds like there's someone mowing the lawn. It does. I don't know if it's our lawn or not. Our grass does need to be cut, so I hope it is. But yeah, that's it. I know it's a lot. I like that actually. 3 hours goes by faster than I thought, but I'm starting to get the feel a little bit more about how a more intermediate exploratory class is going. And so again, we'll make some mistakes. Thanks for bearing with me through it. Shout out the things that you like and that you don't like. And also, like I said, this course we are gonna try to rush through things, but we may extend this course in particular to maybe be 10 weeks. Maybe this needs to be another 12-week one, or maybe all of them when they're 1 day a week need to be 12 weeks instead of 8 weeks. But again, just playing with it, seeing how things fit together. But we'll keep going. This is also not the end of it, so like we can also have this run into the advanced portion or anything like that. And suggestions: if your work environment option is only Jenkins, no, so there's nothing wrong with Jenkins. I can give you some resources for Jenkins. I think that my problem with, I haven't used Jenkins in a long time, so I will say it may be just as easy as the rest. The problem with Jenkins is any old school person has probably had to manage Jenkins servers, and it can be problematic. Jenkins is good to know. I actually highly recommend people learn Jenkins because so many places use it. It is a highly sought after tool. It's a highly sought after, it's good. It does a lot. It does everything, really. It is the most capable, but I think it has the highest learning curve for sure. So yeah, we can give you that. But yes, I'm gonna put do you have the Google Classroom? I'm going to release the quiz shortly. I think there's like a couple more questions I wanted to add, and that's the only reason I didn't release it, but I will release it in a few. What is your opinion on using Nginx proxy instance as a bastion as well? Great question. I'm assuming, so Adam asked about using that service as a bastion. A bastion host is usually you would basically, a common paradigm is to not allow SSH access to any of your servers from the outside, but you create one server that does have access. So basically, for anyone to log into any of your servers, they have to log into this one bastion host, and then from that bastion host, they can log into all the rest of the servers. Yes, I think that's fine. I think that's okay. I don't see any reason why it would be different than anything else. I think it's a little less clean, but I don't see any inherent problems with it, unless that Nginx server becomes your one point of failure, your kind of weak point. Then I think it should be a separate instance, but I don't see any problem with it as being your jump instance. What's even better is nowadays you don't even need a jump instance. We ran into some issues with this, but there is something in Systems Manager if you're using AWS. If you're using AWS, like a newer paradigm is to not allow logging into any of your servers, and using Session Manager to log in if you need to do something, but managing everything else via code. In the beginning of doing something like this, you can't do that. We are not there yet at all, but we will get to the point where this becomes more feasible, where instead of logging in to make changes, we will do everything from code. So yeah, but yeah, I would recommend a separate instance, but if it's a hassle, if it's too much of a hassle, like I don't see a real reason why that bastion host could not be your Nginx server. Security is a multi-layered approach. Need some MFA as well. Yeah, I mean, we have MFA set up for me to log into here, so that's why people are using Session Manager, because you already have that MFA. We're gonna learn about CloudFormation. We might deploy a few CloudFormation templates just so we kind of can see the differences between that and Terraform. But CloudFormation is not a great tool. It's not a great tool at all. But all right, that's it. I actually have a bunch I need to do this afternoon. Thank you guys so much for your time. You always are troopers. A lot of amazing questions. Also, I'm going to try to go through and copy some of these things down. Maybe we'll try to cover some of these. Again, if you didn't get your question answered, please ask it in the Slack or the Discord. I am a CSA associate. I have my associate solutions architect. Sir, I'm working on the pro right now. Definitely working on the pro right now. And for everyone who's, again, you're working on stuff, you're overwhelmed right now. I hear you. But also during the Last Horizons thing. I'm studying for the Solution Architect Pro exam. I've done tons with AWS, and we struggled through something and did not finish what we were trying to finish. So you know, it's okay. Like, we're all learning. So cool, appreciate it. So who are we rating today, so I can go get this food? I'm gonna take a picture of this barbecue, so I'll put it on Twitter. I think this barbecue is gonna be great. Let's head over to someone. Who do we got today? We've got we always give Coding Garden some love, but let's give someone else some love. Let's see. Data Architecture Day with Joe Carlson. I don't know what that is. We headed over to see him. So everyone, I think he clipped it last time we went over to see him, Griffin. He was taking a fat bong rip as soon as we got there. It was kind of perfect timing. He lives in he smokes on the channel a lot. I don't care, but if that bothers you, I'm always surprised that when people are bothered by it, but it's okay if you're bothered by it. You know, hey, I get it. I'm sorry. But we'll try to switch it up. We'll head over to see him, Griffin, another day. Let's try to head over to Data Architecture Day with Joe Carlson. I don't know who this is. I don't even know if it's in English. It says it's English, so we're just gonna try that. So, last raid. All right, everyone, have a good day. Yeah, I mean, we did get an extra plate, Steve. So if you're trying to pay a premium on that, you can absolutely pay a premium on that. But all right, y'all, peace. Also, I'm probably gonna start doing some gaming things on the what's that thing called? Stone Cold Stream Austin channel. I'll share more information about that, but me and some friends are just playing around. Steez is one of them. We're trying to get good at some video games. We're trying to do some stuff with some esports just for fun. But I'll send that out later. But let's go. We got 10. Wait, is this the right person? It doesn't show his face. Oh yeah, it does. This is the right person. Absolutely. I'll see everybody Monday for Horizons or Tuesday for Decoded. Have a good weekend, everybody. Enjoy some time in the sun. Enjoy some time with your families. Enjoy some rest. Let's go.